Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. This is a marathon. Around you will get 6.5 to 7 hours of marathon you will get of previous HPCL papers, HPCL electrical papers. 5 papers are there, 4 HPCL, 1 HRRL. Okay, all the subjects, take it from network analysis, then power system, power electronics, measurements, machines, all these almost 6 subjects you will be getting in 6 to 7 hours, in between 6 to 7 hours. Okay, I'll be starting with the network analysis. Almost 50 questions, nearly 50 questions were asked from the subject network analysis. From power system, almost 60 questions. Overall, I'll be handling 110 questions with the complete explanation with respect to HPCL preparation. Okay, so these are previously asked HPCL paper questions, networks and power system. The same way you'll get other subjects also, right? Yeah. So YourPedia is one of the largest and best platform for the preparation of competitive examinations like HPCL, I can say officers or JUO, these kind of things, and BARC interview preparation and any preparation with respect to competitive examination. You can contact us if you are interested to join HPCL officers module, and we made a very good book for HPCL JUO with more than 2,500 questions in the direction of HPCL JUO examination preparation. If any one of you interested, you can contact us using the number that is mentioned in the description box, right? Yeah, let's enter into the questions. The very first question: in an RL circuit, the inductor has 0 initial current. Yes, the circuit is RL. He is saying circuit is RL. Okay, the inductor has initial current IL of 0 minus is equal to 0. Initial current is represented with 0 minus when the switch is open. Okay, what does the inductor behave like just after switch is closed at t is equal to 0? Do remember here 2 points I'm giving. Point 1, note point that I am giving. Yes, initially 4 statements I'll be giving. 4 statements. Initially means a switch closing or opening, whatever it is, means at the time of operation. Initially, inductor behaves as open circuit. Initially, inductor behaves as open circuit. Initially, inductor behaves as what? Open circuit. Initially, capacitor behaves as short circuit. Inductor as open circuit, capacitor as short circuit. Finally means that it is equal to infinity. Finally, capacitor behaves as open circuit. Finally, inductor behaves as short circuit. You see, this is about inductor and inductor. Initially, inductor as open circuit, finally short circuit. Initially, capacitor as short circuit, finally as open circuit. These 4 statements you have to understand and you have to remember. What is the voltage in a short circuit? 0. What is the current in an open circuit? 0. Right? In open circuit, current is 0. In short circuit, voltage is 0. Sir, what about open circuit voltage? We don't know. That depends upon the circuit configuration. Sir, what about short circuit current? We don't know. That depends upon the circuit configuration again. Right? Now look at the options. Let's read the question once again. In an RL circuit, the inductor has 0 initial current when the switch is open. Okay. What does the inductor behaves like just after the switch is closed at t is equal to 0? Just after closing the switch at t is equal to 0. Inductor behaves as open circuit. Option is C. C for Chennai. Option is C. Let's go to the next question. A series RLC circuit has R is equal to 10, L is equal to 200 millihenry, and C is equal to 50 microfarad. What is the impedance at resonance? See, I will give you. He did not mention as a series resonance or parallel resonance. Whatever it is, few points I will be giving here. See, at series resonance or parallel resonance, at series or parallel resonance, impedance is exactly equal to resistance, since magnitude of XL and XC both are equal. In series, Z is equal to R plus J XL minus XC, both are equal. This will be 0, that is equal to R. Yes, this is for series. In series resonance, in parallel resonance, Z is equal to what? R. First of all, R in parallel with XL in parallel with XC, JXL in parallel with JXC. What you get is JXL into minus JXC by JXL minus JXC. So these two will get cancelled. This is 0. So denominator is 0 means total is infinity. Any resistance in parallel with infinity will be that resistance only. I repeat, any resistance in parallel with infinity will be that particular resistance only. So here, what is the answer? It should be equal to resistance that is A. That is A. Right? That is what? A. Yes or not? Yes. Let's go to the next question. What is the shape of the response curve for series resonance circuit at resonance? Response curve of series circuit. Yes. Resonance, series resonance and parallel resonance I am drawing here. Yes, so this is frequency, this is resonant frequency. See, in series resonance, at resonance current is maximum, this is current is maximum, and impedance is this way, impedance is minimum. So this is current I, this is Z. At resonance, yes, at resonance current is maximum, this is current I, this is impedance Z. Current is maximum, this is I max. Impedance is minimum, this is max, this is min. Impedance is minimum, right? Yeah, current is maximum, current is maximum. Option is D. Look at the options. There are 4 options. Current is 0, no. Current is minimum, no. Impedance is maximum, no. Impedance is minimum. Current is maximum, yes. Current is maximum. Option is D. D for Delhi. Next. In a series RC network, yes, let me take up here. In a series RC circuit connected to an AC supply, okay, the phase angle phi between the supply voltage and current is given by, let's take it, this is R, this is C, this is minus J XC, this is minus J XC. So this is the impedance seen from here, that is Z. Z is equal to R minus J XC, right? He is asking phase angle between supply voltage and current. Voltage divided by current is nothing but impedance, boss. Impedance, Z only, not ZC, Z. Okay. Impedance angle means angle of impedance is equal to angle of angle between voltage and current. Voltage and current. What is the angle? Tan inverse of imaginary part. What is the imaginary part? Minus XC by R. What is XC? XC is equal to 1 by omega C. So from this one angle we want. From this one angle phi is equal to tan inverse of imaginary part minus 1 by omega R C. Options you see. Minus is not there, he did not given, but none of the option is matching except option C. Therefore we can leave that minus sum, but if the minus option is present, we must put that. Why? Because in RC network, current leads, voltage lags. Impedance angle is negative. It means that capacitive in nature. Impedance angle is negative, that means capacitive in nature. Impedance angle is positive, that means I can say inductive in nature. The circuit is inductive in nature. Option is C. C for Chennai. Next step. In an RC circuit, a capacitor has 0 initial voltage, okay, when the switch is open, fine. Just after the switch is closed at t is equal to 0, how the capacitor behaves? Initially t is equal to 0 plus means initially. Means what? Initially t is equal to 0 plus means initially. Initially capacitor behaves as, yes, capacitor behaves as, just now I given 4 statements, behaves as short circuit. What? Short circuit. Initially capacitor behaves as what? Short circuit. Option is A. Option is what? A. Next, an inductor of L is equal to 0.5 Henry carries a current of I of t is equal to 4t amperes for t greater than equal to 0. What is the voltage across inductor at t is equal to 2? Voltage across inductor VL of t is equal to L di by dt. L d I by dt. What is that? I of t, 4t by dt. We want where at t is equal to 2 seconds. Yes, we want at t is equal to 2 seconds. That is 0.5 into 4t derivative is 4. Irrespective of time, the voltage is 2 volts. It is not depending on time. You need not to substitute because 4t derivative with respect to t is 4. That constant will come out of that. 0.5 into 4 is 2. 0.5 into 4 is 2 volts. Yes. Option is A. Option is what? A. Next question. What is the shape of response curve of parallel resonance circuit at resonance is? Yes, parallel resonance. Okay. Parallel resonance impedance is minimum. Impedance is maximum. Sorry. Parallel resonance at resonance impedance is maximum. Current is minimum. Impedance is at resonance, in parallel resonance, at resonance, yes, I can say impedance is maximum. Impedance is maximum and current is minimum. And current is what? Minimum. Right? Next question, please. A series RLC circuit has inductance L is equal to 4 Henry and resistance is equal to 8 ohms and resonates at frequency omega is equal to 50 radians per second. What is the quality factor? What is the quality factor formula? Quality factor Q is equal to energy stored in a cycle. Energy stored in a cycle by in a full cycle, in fact cycle means full cycle, by energy dissipated in a cycle. So quality factor will decide the quality of the coil or capacitor, whatever it is. Means suppose if I take ideal inductor, quality factor is infinity. If I take ideal capacitor, quality factor is infinity. The reason being here is yes, resistance is 0, no loss. As no loss is taking place, their quality factor is infinity. Their quality factor is what? Infinity. Yes or not? But here for this one he given for inductor the quality factor formula is it's a practical inductor. Why? Because it is having some resistance. It's a practical inductor. Why? Because it is having some resistance. Omega L by R. Resonance frequency we have to take omega L by R. How much is omega ma? Omega is 50. L is 4 divided by 8. 4 2s. This is simply 25. No units. Quality factor does not have any units. Why? Because the ratio of energy to energy, energy by energy, na? So therefore no units, right? Next, a series RL circuit with R is equal to 5 ohms, L is equal to 2 Henry and a 10 volts DC source is in steady state at t is equal to 0. The switch is moved to connect only the inductor and resistor. R is equal to 10 ohms. What is the current? Okay, let me read the question once again. A series RL circuit with R is equal to 5 ohms and L is equal to 2 Henry. Okay, so he is saying there is plus minus 10 volts DC and there is a switch, a resistance and inductance was connected. This is 5 ohms and this is how many? 2 Henrys. And it is in steady state, means the switch is closed long back. Okay, now about the switch, as the switch is closed long back, I'll put like this. I will put like this: a switch switch is closed long back, it is in steady state. Steady state means final, means this will be short circuit as I told you. How much is the current? 10 divided by 5, 2 amperes is the current. 2 amperes is the current. Okay, inductor does not allow sudden change in its current. What is the current? Till now it is having 2 amperes. Now he is saying he is changing the switch. Switch is moved to connect only the inductor and a resistor of 10 ohms, means the switch is made in such a way that this particular thing is removed and 10 ohms is connected here. Whatever you do within 0 time, current will not change. Let me write a note point here. Inductor does not allow, inductor does not allow sudden change in its, inductor does not allow sudden change in its current, comma, capacitor does not allow sudden change in its voltage, Okay, inductor does not allow sudden change in its current, capacitor does not allow sudden change in its voltage. The current will remain same. Sudden change is not accepted, gradual change is anyhow accepted, right? Option is B, B for Bombay, that is 2 amperes, right? Option is B. Next question. A series RLC circuit has L is equal to 50 millihenry, yes, L is equal to 50 millihenry, C is equal to 20 microfarad, R is equal to 10 ohm. What is the quality factor? As I told you, omega L by R. See, in using both the formulas you can find Q is equal to omega L by R, omega not given, okay, series RLC circuit, okay, fine, L is equal to given, C is equal to given, and yeah, fine. We will see that omega L by R. What is omega? Resonant frequency I have to take. During resonance, what is omega formula? 1 by under root of LC, that is equal to L by R. People may complain, just I got stuck for 5 seconds. Why? Because I was searching for omega, but omega are not required. Why? Because omega are equal to 1 by root LC, right? So root L times gone, that is 1 by R into under root of L by C. How much is resistance? 10. How much is L? Is 50 milli divided by, how much is capacitance? 20 micro, 20 into 10 to the power of minus 6, right? If we solve this, what we get? So 10 to the power of 3 we get extra here, this 0 gone, okay. Now what we are left with is a 10 is inside, outside, let's send it to inside. What will become? It will become 10 square 100 under root of 10 cube divided by 2 into this will become 100, 2 into 100, so under root of 10 I think divided by 2 root 5, but options it is not there. In options it is not there. Maybe it may be a typo, okay. Quality factor formula is perfectly correct. See my calculation, if any calculation mistake I committed, observe it once, okay. Omega L by R, R 1 by omega RC also. Sir, for capacitor Q factor is equal to 1 by omega R into C, but what is omega? 1 by root LC, that is root LC by R into C. So root C times it is gone, that is equal to 1 by R into again under root of L by C. 1 by R into under root of L by C only, right? 1 by R is 10, under root of L is 50 into 10 to the power of minus 3, C 20 into 10 to the power of minus 6, 20 into 10 to the power of minus 6, 0 gone, right? So this 10 to the power of 6, when it goes to upside 10 cube, it will become 1 10 to the power of minus 3, 1 10 to the power of minus 3 gone, 0 gone, under root of 5 by 2. When that 10 goes inside, 5 into 10 cube, 5 into 10 cube divided by 200. Yeah, I think 5 is there here. I forgot about this 5. 5 into 10 cube. Yeah, that's why I got wrong answer. 5 into 10 cube. Okay, here 5, how many times it will go? 20 times, right? So this is 10 square divided by 100 divided by 2. Then also it is root 50. You look after this calculation part, I am leaving it to you. Okay, next question. A capacitor C is equal to 20 microfarad in an RLC circuit has voltage across it given by V of t is equal to 100 sin 2000 t. Okay, what is the instantaneous current through the capacitor at t is equal to 0? So at t is equal to 0, current in the capacitor is maximum. See why? Because the relationship between voltage and current of a capacitor is this one. So voltage he given 200 sin t, sorry, 100 sin 2000 t. This is the voltage. This is the voltage. This is V of t. Then current will be this way. Current will be maximum. Current will be this way. Current leads this one by 90 degrees, right? So maximum current, what is IC? First of all, IC is equal to voltage. How much? 100. Let's take it at an angle of 0 divided by XC. How much is XC? 1 by omega C. So 1 by omega C means into omega C into omega C. Omega is how much? 2000 into C is how much? 20 into 10 to the power of minus 6. 100 angle you can leave it off. Angle you leave it off. So 10 cube 10 square means 2 into 10 to the power of 6 into 10 to the power of minus 6. This is simply 4 amperes. 4 amperes. RMS value, not RMS value please, maximum value only, because this I taken maximum value, VM I taken, this is a maximum value only. Yes, current at t is equal to 0 is the maximum, not the RMS value. Option is D. D for Delhi, it is 4 amperes. Simple question. But simple but logical it is. Simple but logical it is. Yes. If you observe it carefully, you will understand it is simple, but it is logical, right? Let's go to the next question, please. What is the next question? An inductor of L is equal to 2 Henry is connected to a DC voltage source of 10 volts at t is equal to 0 seconds. What is the rate of change of current through the inductor just after the switch is closed? Okay, what he is saying, yes, let me take up the circuit here. This is a DC voltage source. To this one, an inductor is connected. This is L. How much? L value is 2 Henry. The switch is closed at t is equal to 0. This is plus minus 10 volts. So VL formula is what? L di by dt. So di by dt is equal to VL by L. What is the voltage across inductor? VL by L, please, not VL. VL by L. What is the voltage across inductor? Same 10 volts will appear across this. 10 divided by L is 2. 5 amperes per second. Yes, 5 amperes per second. Option is D. D for Delhi. Option is D. D for Delhi. Right? Next question. See, this question we have to do in S domain. S domain. So for that, see, time domain, and this is a frequency domain or S domain. This is a frequency domain or S domain, both are same. Resistance is resistance only. Inductance will be Ls. Capacitance will be 1 by Cs. So this is 4 ohms only, right? This is 6S. This is 2 ohms only. This is 1 by 5S, right? 1 by 5S. Let me write here. Apply voltage division. Voltage division. What is that? Voltage division. What is that voltage division? Yes, V naught of S is equal to, what is voltage division? This is VA of S. VA of S, this is V naught of S. Output voltage is equal to input voltage into output impedance 2 plus 1 by 5S by total impedance 4 plus 2 plus 4 plus 2 plus 6S plus 1 by 5S. Right? If you solve this, you'll get, I'll solve for you this one. Observe carefully, please. Okay, so V naught by VI is equal to, this is 10S plus 1 by, how much it is? 4 5 is 30S square. Yes, 6 30S square, 6 into 5, 30S plus 1. 30s plus 1, 10s plus 1 by 30s square. Yes, 10s plus 1 by, you can take total 30 common. Okay, if you take total 30 common, option D for Delhi is perfectly suitable. Option D is perfectly suitable for this given question, right? Option D is perfectly suitable for this given question. Yes or not? All of you, yes. Let's go to the next question, please. Next question. Yeah, what he's saying. Study the given circuit figure and find the output voltage V0. He is asking V0. Here, as he given, I can say, other than sinusoidal function, always it is better to go with the Laplace transform. Other than sinusoidal, he given, go with the Laplace transform. What this will be? He is asking about this voltage. This voltage is asking. Okay. First of all, I need to find this current. IC of S means in S domain I will find. Now, what is this current will be? This is 4 by S plus 1, right? Now, this is 10K only, but this 20 microfarad will be 1 by C is 20 into 10 to the power of minus 6 into S. So, that will become 10 to the power of 6, means 10 to the power of 5 divided by 2, means 10 by 2 is 5 into 10 to the power of 4. 5 into 10 to the power of 4 divided by S. Correct me if I am wrong, okay, in the calculation. I don't think I am wrong in the calculation. So 50K by S. This can be written as what? 50K by S. 1 by CS. 20 into 10 to the power of 6 minus 6 into S. The 10 to the power of minus 6 will go upside. 10 to the power of plus 6. In 20, 110 is there. 10 to the power of 5 will be left. In 10 to the power of 5, 110 I keep it aside. In the numerator, 10 by 2 is 5. 5 into 10 to the power of 4. 50K by S. Okay. This is 10K. Now, current in the capacitor, current division. What is that? Total current into opposite impedance is R. How much it is? 10K by total. How much it is? 10K plus 50K by S. 10K by 10K plus 50K by S. Let's do in the next page. Let's do this one in the next page. That is 4 by S plus 1 IC of S is equal to 4 by S plus 1 into S. A small simplification I will be taking up. I can say that S will come upside. 10Ks by 10Ks plus 50K. 10K into S by 10Ks plus 50K plus 50K. I want voltage. VC of S is equal to this total current into impedance S plus 1 into 10K into S by 10K into S plus 50K into the impedance here is how much? 50K by S. 50K by S. This S will get cancelled, right? That S and S will get cancelled. Now we have to apply inverse Laplace transform for this one. Now VC of S is equal to 4 by S plus 1, keep it aside. This K gone. Okay. Yes, K gone. So 10 by S, 10S plus 50. Let's take 10 also common. Then what happens is 10 will get cancelled. S by S plus 5 into 50K. Somewhere we committed a mistake in the calculation. Huh? Let's see. Okay, well, 50 will be there anyhow. Let's leave it. Now apply inverse Laplace transform to this. VC of S is equal to partial fractions 50, keep it aside. Okay, or let us check this way. Why to find all this partial fractions and then inverse Laplace transform? Check this way. Okay, in what way we have to check, sir? At t is equal to 0. At t is equal to 0, this current is 4 amperes. That way we can check at t is equal to 0, but it is not possible. Calculation is exceeding. But one thing is sure. One is this will give e power minus t. This will give e power minus 5t. At least from that we can check instead of doing the calculation. e power t, e power minus t, all 4 options are having the same. 50 should be there, either option A or D. B and C are not correct. Into 50 is there, or shall we do it, complete the calculation? Why? Big calculation is becoming, I don't know, any calculation mistake if we committed, please let me know. Okay, any calculation mistake if we committed, let me know. Why? Because 50k we are getting 4 by s plus 1 into opposite impedance, 10k by 10k plus 50k by s. Okay, that's fine. S gone to the upside. Yes, 10ks plus 50k into its reactance is 50k by s. 1 by cs is 50k by s. Okay, so k gone. Okay, and 10 gone. Then we are left with s by s plus 5 into 50k. Correct only. Nowhere we committed any mistake. Okay, let us see. 50k into 4, let's keep outside. 50k into 4, let's keep outside. This is s plus 1. This is s plus 5. Put the partial fractions. Put s is equal to 0. If I put s is equal to 0, leave these two things. This one you leave it. But if I put s is equal to 0, I'm getting it as 0. Somewhere we committed the calculation mistake, but the procedure is this one only. You just do the procedure. In the calculations, I think somewhere I committed the mistake. You don't commit any mistake. Do that, you will get. Okay, that's not a big deal. Let's go to the next question. What will be the transfer function of the network shown in the figure? What transfer function is very easy, This is 1 by cs in S domain. This is V naught of S, it will become. This is VA of S. This question, there is some calculation mistake I committed. I don't want to waste our valuable time in doing this calculation. That's why I'm leaving it to you, right? Next, what is V naught of S? V naught of S is equal to VA of S. Yes, input voltage into output impedance by total impedance. What is transfer function? Laplace transform of output voltage by Laplace transform of input voltage. This will be simply 1 by SCR plus 1. What is this? 1 by SCR plus 1. But that fellow even did all that. V naught of S by VA of S. What is transfer function definition? Just is asking for the definition, that's all. Transfer function is equal to Laplace transform of the output variable, Laplace transform of the output variable by Laplace transform of the input variable. Laplace transform of the output variable by Laplace transform of the input variable. What is the output variable here? Output variable is V naught of t. V naught of t, I can say Laplace will be V naught of S. Input is VA of t, its Laplace is VA of S. Yes? Yes or not? Clear? So option is A. Option is A. Very simple thing. Next, study the given circuit. Find the equivalent inductance between terminals A and B. Yes, he is asking between the terminals A and B. See, I will draw this one in the form of a bridge. Okay. Let us take this way and see for bridge balance. Let's take this point as A. Let's take this point as B. This point as B. Okay. Let's take this one as C, this point as D. Okay, A to C, 10 Henry is there. Let's take this one as C, this one as D. Okay, this is A. A to C, in between A to C, how much is there? 10 Henry is there. I'm not writing that H, 10 Henry is there. C to D, 27 is there. C to D, 27 is there. D to B, yes, how much is there? D to B, 24 is there. Yes. B to C, 16 is there. D to A, 15 is there. Yes, 15. Yes, this is simply bridge. This is simply a bridge. Now check for bridge balance. What is bridge balance? If bridge is balanced, that middle thing can be neglected, means can be completely removed, not neglected. We are not neglecting, we are completely removing it. Why? Because if the bridge is balanced, in that middle element, no current will flow. If current is not flowing, that can be treated as open circuit, right? Now, what is the condition for bridge balance? Opposite arms product, either it is resistance or inductance. What is that? 10 into 24, we want to be equal to 15 into 16. 15 into 16. How much is 10 into 24? This particular value is 240. How much is 15 into 16? I'm using my cell phone calculator to do that. Okay, 15 into 16. But you must be good at calculations. Why? Because in your examination, calculator is not allowed. That is also 240. Yes. This is also 240. As 240 and 240 both are equal, this middle thing can be neglected. If we neglect that middle thing, we are going to have bridge this way we are going to have, right? This and this. Now these two are in series. What are those two values? 10 and 16. This is a 10, this is a 16. Yes. And 15 and 24. Yes, this is 15, this is 24. 10 in series with 16 is 26. Yes, 26. How much is this? 39. Yes, this is 39. Yes, 26 in parallel with the 39. Let me calculate. 26 into 39 divided by, how much is 26 plus 39? 50, 65, right? 65. It is exactly 15.6 you will get. Yes, this is L equivalent. L equivalent is, if it is taken as L1, if it is taken as L2, L1 L2 by L1 plus L2, you will get it as 15.6 Henries. Option is C for Chennai. Option is C for Chennai, right? Next, let's understand what is the question here. An RC series circuit has resistance of 100 ohms and a capacitance of 100 ohms. The phase difference between the voltage and the current. Yes, previously we got a phase difference phi is equal to minus. I am not taking. We all know that current leads the voltage by some angle in RC network. In RL network, current lags behind the voltage. What is the formula? Phi is equal to tan inverse of XC by R, that is 1 by omega RC. 1 by omega R into C, but he did not mention, not required. Yes, he already given XC, no? By omega we have to put XC by R. XC is 100, yes. R is also 100. Tan inverse of 1, it is 45 degrees. What is the statement here? The statement here is current leads, yes, I repeat, current leads the voltage by 45 degrees. Read the options and tell me which option is correct. Read the options and tell me which option is correct. Yes. What is option A? Current will lag. No. Current will lag. No. Current will lead the voltage by 90 degrees. When it will be 90? If it is ideal capacitor, current leads the voltage by 90. But it is a practical capacitor. It is a practical capacitor, so it is not going to be 90, it is other than 90. That is the value we calculated, how much it is, 45 degrees. Option is D for Delhi, right? Let's go to the next question. Calculate the transfer function. Yes, there are two capacitors in parallel. 4 farads and 2 farads will be 6 farads. Capacitance in S domain will be 1 by CS, 1 by 6S. This is V naught of S. This is 1 by 2S. This is VA of S. This is what? VA of S. So V naught of S is equal to VI of S into voltage division. Output voltage is equal to input voltage into output impedance. 1 by 6S by total impedance. 5 plus 1 by 2S plus 1 by 6S, right? Yes or not? Let me calculate in the next page. Right? V naught of S by VA of S is equal to V naught of S by VI of S is equal to 1 by 6S plus 1 by 2S. 1 by 6S by yes, 5 plus 1 by 2S plus 1 by 6S. 5 plus 1 by S, let me take common 1 by 2. 1 by 2 plus 1 by 6. 6 will be the LCM, right? 6 will be the LCM. This is 3 times. And how much is this? This is 1 times, right? 1. Correct or not? Yes, correct only. 3 by 6 is 2. 1 by 6 is 1 by 6. That's all, right? So 1 by 6S by 30S plus 4, yeah, by 6S. 6S gone. So 1 by, if I take 30 common, S plus 4 by 30, S plus 4 by 30, right? So if I solve this, yes, options you see, 3 by 4S plus 30, no. SC is going to have 30, no, not correct. Yes, 0.03 by S plus 0.12, yes, correct. So 1 by 30 will be 0.033 something you get. S plus 4 by 30 will be 0.12. Option is B for Bombay. Option is B for Bombay, right? Next question please. Next question. Which of the following options is the transfer function of the given circuit? Again same. This will be 3S in S domain. This is V0 of S. Okay. This is total 4 ohms. This is Vi of S. So V0 of S is equal to Vi of S into load impedance 4 divided by total impedance 4 plus 3S. 8 plus 3S. 8 plus 3S. So from this one, V0 of S by Vi of S is equal to, if we take 8 common in the denominator, yes, let's take 3 common in the denominator, 3. So 4 by 3 by S plus 8 by 3. 4 by 3 by S plus 8 by 3. Option is C, C for Chennai. Option is C, C for Chennai. Next. Study the given circuit. Okay, what is saying? What will be the reading of ammeter? He is saying ammeter reading he is asking. In fact, here 0.1 ohm is there. There is a resistance of 0.1 ohm. I am putting here 0.1 ohm. These two are parallel, 0.2 in parallel with 0.2 will be 0.1, right? 0.1, this 2, this 0.1, all three are in series. Therefore, the total current that is coming from here, I, is equal to Ohm's law, 1.1 divided by 2 plus 0.2 is 2.2, that is 0.5 amperes. That 0.5 amperes will enter into the ammeter, Option is B, B for Bombay, that is 0.5 amperes. That is how much? 0.5 amperes. Yes or not? Yes. Let's go to the next question. Study the given circuit. Calculate the power dissipated by 4 ohm resistance. 4 ohm resistance, right? As it is DC. Yes, the given supply is DC. Why? Because it did not mention any frequency. For DC, yes, inductor behaves as short circuit. Inductor behaves as short circuit. Now this current I want. Now this 10 volts is exactly in parallel with 4. I is equal to 10 divided by 4. How much it is? 2.5 amperes. Or directly power dissipated by any resistance is equal to voltage across that resistance. Across 4 ohms we have 10. V square by R 100 divided by 4. It is 25 watts. Very simply. What it is? It is 25 watts, but it is not there in the options. I think something is missing in the question. There is a typing mistake. Because 4 ohms resistance is asking, everything is no. It is not DC. It is not DC. We taken it as wrongly as DC. It is not DC. Why? Because inductance is given as J4. If it is given as J4, no more it is DC. It is AC only. Why? Because XL is equal to 2 pi FL. XL is equal to 2 FL. Study the given circuit. Calculate the power dissipated in 4 ohm resistance. Means I want to find this current. But how to find this current? No, that is very lengthy. We can do that. some statement is missing in the question. He may be asking find the current in the resistance because of only 24 volts. Something he has to say, he need to say. But because if this is J4 ohms, this is J4, it mean to say there is some frequency. Frequency is not equal to 0. Sir, how do you know? XL is equal to 2 pi FL. XL is equal to 2 pi FL. If this is non-zero, means F is non-zero. How much is the frequency? We don't know. Sir, what is the purpose of frequency? Yeah, there is no use of frequency, but I want to find this current. I want to convert this one as current source, this one as current source, then apply current division, get this current, then apply the formula. Lengthy. There is something that is missing in the question. From the actual question statement, something is missing in this. Okay, we'll see that when I discuss power systems at that point of time. I will come to this question once again. What is the mistake in this question, right? Next, study the given circuit, convert delta network into equivalent star. Delta to star. How to find? See, let's take this one as R1, this one as R2, this one as R3. So this we get, this we get, this we get. So connected resistances multiplication R1 R2 by R1 plus R2 plus R3. I'll take this R1 plus R2 R3 as delta for my easy understanding purpose. I don't want to write again and again all this. Now this one will be R2 R3 by delta, R2 R3 by delta, and I can say this one will be R1 R3 by delta, R1 R3 by delta. First, if I add those three, 30 plus 40, 70 plus 30, 100, delta is 100, delta is 100. What is this value? Means RA. Yes, this fellow told us this one as RA. 40 into 30 by divided by 100. 40 into 30 is 1200. 1200 divided by 100, it is 12 ohms. RB is 40 into 30. This is also 12 ohms. This is 30 into 30, 900, means this will be 9 ohms. Simply 12, 12, 9. Option is A for apple. Option is A. Simple question. Next, what does the transfer function E naught of S by E of S 1 by R1 CS plus 1 represents? See, an RC circuit. Simply you do remember, need not to read all the options. Simply a series RC circuit with the output voltage across capacitor. This is V naught of S. This is Vi of S. This acts as, this behaves as low pass filter. An RC circuit simply behaves as an low pass filter with what is cutoff frequency? Cutoff frequency is 1 by R1C. Tau is equal to R1C. See, tau is equal to R1C. Frequency will be reciprocal of that 1 by R1C. 1 by R1C, right? Next question. And an AC circuit with voltage V and current I, current I and resistance R, and the impedance Z, the power factor cos phi is given by, yes, power factor is equal to real power by apparent power. What is P is real power or active power, S is apparent power, whose magnitude is root of square of summation of the root of the square summations of the real power and reactive power. Q is the reactive power. That is equal to R by magnitude of Z. That is equal to R by root of R square plus X square. R by Z. It is what? Cos phi is R by Z. R by Z. Yes or not? Option is C. C for Chennai. Next. In an RL circuit with a resistor R and inductor L in series, a step voltage V0 is applied at t is equal to 0. What will be the initial current I of 0 in the circuit immediately after the step voltage is applied? As I told you, before closing the switch, current is 0. Immediately after closing the switch also, current will remain as 0. Why? Because inductor does not allow sudden change in its current. Yes, this statement I already wrote. I am not writing again here. As inductor does not allow sudden change in its current, so immediately after closing the switch, before closing the switch anyhow current is 0. Why? Because switch is open. Now if you close the switch suddenly and immediately after closing the switch, current will remain as 0. Why? Because inductor does not allow sudden change in its current. Option is A. Option is A. Next question. Which of the following is true regarding Kirchhoff's voltage law, KVL. See, KVL says sum of all the voltages in a closed path must be equal to 0, and it is derived from law of conservation of charge. Energy. KCL is derived from law of conservation of charge, but KVL is derived from law of conservation of energy. Is derived from what? Law of conservation of energy, right? Yeah. Let's read the first statement and second statement. The sum of rises of potential around any closed circuit equals to the sum of the drops potentials in the circuit. Perfectly correct. Voltage rises means sources. Voltage drops means voltage across resistances. Sum of all the rises plus drops is equal to 0, or rises must be equal to drops according to means if you take only magnitude. General expression for KVL is sigma j is equal to 1 to k, Vj is equal to 0. That is also correct. That is also correct. Both the statements are correct. Both the statements are correct. Both 1 and 2 are correct. Option is C. Both 1 and 2 are correct. Next. Which of the following equation is correct regarding the given circuit diagram? Given circuit diagram. So this is I1. Yes, I'm noting down here. This is I2. This is I4. This is I6. This is for me it is not looking clearly. Yes, this is I5. Let's take. Then what it is left? This is I3. Yeah, let's take I3. No issues. But the diagram is not that clear. This is I7. Let's write. At node A, I1 plus I4 is equal to I2. Yes. Yeah, what it says, KCL, I1 is incoming. Yes. I4 is also incoming. I1 plus I4 is equal to I2. Yes, correct. This is correct. At node C, this is C. This is I7. I5 is incoming, is equal to outgoings are I6 plus I7. I5 is equal to I6 plus I7. Correct. Statement 2 is also correct. At node B, I2 plus I3 is equal to I5. At node B, I2 is incoming, I3 is also incoming, outgoing is I5. All three are correct. 1, 2, 3, all three are correct. 1, 2, 3, all three are correct. The markings what I taken are perfectly correct. As it is not visible to you, I marked the currents again. Next question. Which of the following statement is correct? Transient response of an electrical circuit can best be described by a linear differential equation. Yes, we can happily. Laplace transformation is a very powerful method of solving linear differential equations. Yes. See, any circuit containing energy storage elements like inductance and capacitance, if you write its transient equation, that equation is going to be a differential equation. That too, it is going to be a linear differential equation. Right? It's a linear differential equation. Yes, and we are using Laplace transform. Yes, we are using Laplace transform for solving linear differential equation. Yes. So both the statement 1 and 2 both are correct. Statement 1 and 2 both are correct. Option is C for Chennai. Next. Which of the following is correct regarding Laplace transform? Laplace transformation also provides the direct solution of non-homogeneous differential equations. Yes, correct. This method automatically takes care of initial conditions without the necessity of first determining the general solution and then obtaining the particular integral. Yes. Means you need not to struggle for, because when we are applying Laplace transformation itself, the initial conditions will be taken care of. Both 1 and 2 are correct. Both 1 and 2 are correct. This is related to Laplace transform mathematics. Next, if the frequency domain network having n principal nodes, one of them is designated as a reference node, and we require dash node voltage equations to solve for the desired result. See, number of nodal equations required, number of nodal equations required, I'm not writing that word required, is equal to n minus 1, where n is number of nodes. Number of mesh equations required is equal to I can write B, number of branches minus number of nodes plus 1, B minus n plus 1. So these many mesh equations are required. Answer is n minus 1. Option is D for Delhi. Principal nodes only. This where n is number of principal or independent nodes. Principal or independent nodes. Next question. Delta to star conversion previously we taken already. So this particular Rx, this is R1, this is R2, this is R3. So this is Rx, this is Ry, yes, this is Rx, this is Rz. So Rx, this is Rz, no, this is Ry, this is Rz. Rx is equal to R1 R2 by total. What is that? R1 plus R2 plus R3. Ry, let's take this one as delta. Ry is equal to R1 R3 by delta. Rz is equal to R2 R3 by delta. R2 R3 by delta. Is asking for Rx only. Why we found unnecessarily Ry and Rz? R1 R2 by R1 plus R2 plus R3. Option A is correct. That's all. Option A itself is correct. Next question. The Laplace transform of any given function f of t will be integral of minus infinity to plus infinity that function into e power minus st dt. This is called as bilateral Laplace transform. Sir, if he mentions nothing, if he is not saying is it required to find unilateral or bilateral, by default it is bilateral. See, and another is integral 0 to infinity that function f of t into e power minus st dt. So this is called as unilateral Laplace transform. Yes. Sir, if nothing is mentioned, we will find this one. If he mentioned separately unilateral, we have to find this one. But in the options, everything he given as 0 to infinity, option B is correct. Option B, B for Bombay is correct. Option B is correct, right? Next question. The Laplace transform of exponential function is described by, see, Laplace transform of e power at into u of t will be 1 by s minus a. 1 by s minus a. Yes, Laplace transform of the exponential function is described by, options are there in the S domain? No. So here we have to get 1 by s minus a. 1 by s minus a. This is 1 by s plus a, and this is e power as. This is e power minus as. All these are f of s, capital F of s. Okay, capital F of s. Option is 1 by s minus a. Option is D, right? Next question. Which of the following is stated as final value theorem? Final value theorem in time domain, t tends to infinity. Final value is equal to t tends to infinity f of t, or limit t tends to infinity s tends to 0, s into f of t will be f of s. F of t will be f of s. You will check that. S tends to 0. Yes, option is a D. Limit s tends to 0, s into f of s, that is equal to limit t tends to infinity f of t. Option is D, D for Delhi. Which of the following statement is correct regarding mesh analysis? The mesh current analysis technique is applied for networks with independent sources or with dependent sources where the controlling variables are not part of the network under investigation. Statement 1 is wrong. Why? Because definitely the variable must be I can say that controlling variable must be part of the network under investigation. See, I'll read the statement 1. The mesh current analysis technique is applied for networks with independent sources or with dependent sources. Up to there it is correct. Where the controlling variables are not part of the network under investigation, no, controlling variable also must be part of the network. I repeat, controlling variable also must be part of the network, otherwise it is not possible. Right? Yeah. Statement 1 is wrong. If the controlling variable is part of the network being examined, additional care must be taken while applying the mesh current analysis technique. Yes, yes. Statement 2 is perfectly correct. Only 2 is correct. Only 2 is correct. Only 2 is correct. Right? Next question. Which of the following equation is stated as initial value theorem? Initial value theorem means what? Limit t tends to 0. Initial value means what? Limit t tends to 0 f of t, but that is equal to limit s tends to infinity s into f of s. This is in s domain, but both must be equal. In fact, s tends to infinity we have to take. S tends to infinity s into f of s. So option is B. B for Bombay. Option is B. B for Bombay. Right? Next question. Which of the following is correct statement? Star connection also can be termed as T connection. Yes. Yes. Star connection or T connection. Yes, this is star only. Delta connection also can be named as pi connection. Yes, sir. Delta connection or pi connection, same. Star network, delta network. Yes, both are correct. Both 1 and 2 are correct. Both 1 and 2 are correct. Next question. Yeah. In a simple coplanar network, there are 7 branches. Number of branches is equal to 7. And junctions, 4 junctions, number of nodes is equal to 4. How many mesh currents are required? Previously given number of mesh equations is equal to branches minus nodes plus 1. How many? 3 plus 1, 4. 4 mesh equations are required. Option is C. 4 mesh equations are required for that to solve. 4 mesh equations are required, right? Next question. Find R equivalent in the given circuit. 52 ohms are in series in top branch. 15 plus 52 in series. 15 plus 52 is how much? 67 are in series in top branch. 20 ohms and 28 ohms are in series in the middle branch. 20 and 28, 48 ohms in the middle branch. 25 at the bottom. 25 at the bottom between terminals A and B. This is 25. So this is A, this is B. This is the circuit, I guess. Okay. All 3 are in parallel. R1, R2, R3 by what we get? R1, R1, R2 plus R2, R3 plus R3, R1. Or simply to speak, I'll do 1 by R equivalent. All 3 are in parallel. 1 by R equivalent is equal to 1 by R equivalent is equal to 1 by 25 plus 1 by 48 plus 1 by 67. Right? 1 divided by 25 plus 1 divided by 25. I am doing with my calculator. So 1 by R equivalent is equal to, this is 0.04 plus 1 by 48. 1 divided by 48. So 0.02833 plus 1 by 67. 1 divided by 67, 0.014. 0.014923 something. Let me add these things. Plus 0.0283 plus 0.04. 0.083. 1 divided by 0.083. 12 something I am getting. Means this is not the combination. This is not the combination. Find R equivalent in the given circuit. 15 and 52 are in series in the top branch. 20 and 28 ohms are in the middle branch. And 24 ohm at the bottom. All between terminals A and B. Correct only. See, ours is correct. Any mismatch of the data you can take care. Just all they are in parallel combination you can take. Right? Next. Yes. Next. Mesh cannot be defined for non-planar. Yes. The circuit must be on a 2D plane. It's not 3D. Means on a plane, on a paper, the circuit must exist. No crossovers. No crossovers. Okay. Every element must fit on a paper. It should not be into the I can say plane, into the plane, only on that plane. Okay. For non-planar, mesh analysis is not valid. We can't apply. Find the current I in the given circuit. 12 volt source, 100 ohms in series. 12 volt source. Okay. 12 volt source, 100 ohms in series. Okay. 40 ohm and 300 ohm are in parallel. Yes. 400, sorry. This is 400, this is 300. Both are in parallel. This is 400, this is 300 are in parallel. He is asking this current I. So 400 in parallel with 300. Yes. 400 into 300 divided by 700. 171 plus 100 ohms, that is 100 ohms please, 100. Okay, so 12 divided by 271, 12 divided by 271, so 0.04. Here also see, I think there are few mistakes in the typing. Yeah, see 12 volts, okay, 100 ohms, okay, in series, 400 and 300 are in parallel, just finding the current. Okay, that's a direct question. There is some mismatch of the data, you can leave it off directly. I given you the circuit, that's all. Determine the voltage at node A and node B in the given network. Here network is missing. 3 amperes current source, 2 ohms between A and B, 3 ohms at node A to ground, 1 ampere current source. So circuit, what is saying? 3 ampere current source, okay, 3 amperes is the current source, okay. 2 ohms between A and B, yes, let's take this one A. 2 ohms between A and B, 3 ohms at node A to the ground, yes, this is 3 ohms. 1 ampere current source, where 1 ampere current source I have to take? So here 1 ampere current source, maybe. See, question is very easy, but circuit is missing in this one. He's asking, suppose if he's asking about VA, we can easily find it out. Convert this one into voltage source in series with resistance. We get it as 9, okay, and this is 3, this is 9 plus minus, this is A, this is 2 ohms, and this is B, this is 1 ampere. This is what? 1 ampere. Now this is plus minus 2 volts, this is plus minus 3 volts, right? Now I want this VA voltage, apply KVL this way. This is plus minus VA, minus 9 minus 3 plus VA is equal to 0. VA is equal to 12 volts. Yes, VA is equal to 12 volts. See, data is mismatching. See, simple question only, there is some small missing thing in the data. There are 3-4 questions in which data got missed. That's not a big deal, okay, but easily you can understand. For a series RLC resonance circuit, 2 half power frequencies are 36 and 25 kilohertz respectively. Find the resonant frequency. Resonant frequency is equal to root of 25 and 36. You will get the answer. Under root of 25 into 36 kilohertz will be the answer. Just you simplify, you will get that answer, right? Next question. Find the voltages at node B in the given circuit. 10 volt source, 10 ohms and 40 ohms resistance. Here also circuit is missing, leave it off. Circuit is missing. Find the current IM in the given circuit. Here also circuit is missing. 5 amperes current source, 40 ohms in series, okay, 10 ohms in parallel, 5 amperes current source, this is 5 amperes current source, 40 ohms in series, 10 ohms in parallel. 10 ohms in parallel to whom? I'll do one thing. See, there is from this question onwards, what are the missing data? Let me add, and we will proceed further, okay. After this, remaining, how many questions are there remaining? There are some 10 more questions, or I can say 15 more questions are there. We'll solve these questions. Let me add the circuits of those questions for which circuits are missing, right? Yes, sir. This is a circuit. Actually, find the R equivalent in the given circuit, 15 ohm. See, this is this is 52 plus 28. Yeah, 52 plus 28, 70, 80, this is 80 ohms, right? 80 in parallel with 20, 80 in parallel with 20, 80 into 20 by 100, 0, 0, 0, 0 gone, it is 16. This entirely is 16. 16 in series with 15 plus 25. How much it is? R equivalent is equal to 15 plus 25, 40 plus 16 is 56 ohms, that's all. Answer is 56 ohms. When we tried the last time, this diagram was missing. We tried to draw using this statement, which we drawn wrongly. That's why we did not got the option. Now it is perfectly correct. Now it is perfectly correct, right? Answer is 56 ohms. Easy question. As I told you in the previous discussion itself, that all are easy questions only, but there are some small typing mistakes. Yes, here the diagram is missing. He is asking for the current. Find the current I in the given circuit. 12 volt source, 100 ohms in series, 400 ohms and 300 ohms in parallel. But the diagram is not saying both are in parallel. Just I is equal to what? I is equal to what? 12 divided by 3, 4, 7, 800. That's all. 12 divided by 800. So I is equal to how much it is? 4 3s, 4 200s. So 1 by 100 into 3 by 2 is 1.5. So I is equal to 0.015 amperes, simply 0.015. Yes, circuit is important for us than this statement. Yesterday we tried according to that statement, it was wrong. Okay, it is 0.015, right? Next, this question is asking for VA and VB. VA, this is A, this is point A, this is point B. This is 2 ohm, this is 3 ampere current source. Yes, this is 1 ampere current source. Yes, this is 3 ohm and this is the ground. This is 0 volt. VA we want. Now tell me, this is 3 amperes, this is 1 ampere, this is going to be 4 amperes, this is plus, this is minus 8 volts. 8 volts, right? Now again 4 amperes is coming from here, 3 ampere is going this way, remaining 1 ampere is entering here, plus 1, this is 3 volts. Now VA is equal to 3 volts. VA from here to the ground, yes, to the ground, between A and ground, how much is there? 3 volts. VB, yes, this is VB. From here I can't go this way. Why? Because current source voltage is unknown for us. I can't go this way. Current source voltage is unknown for us. I can go this way only. What is that way, sir? What is that way? Start from here, go this way. Start from here, go this way. See, I'll write minus VB. See, I'll take this one as some voltage source, plus minus VB plus 8 plus 3 is equal to 0. VB is equal to simply 11 volts. 3 volts and 11 volts. 3 volts and 11 volts. Option is D, D for Delhi. Option is D, D for Delhi, right? Next question. This one we already solved. Root of F1, F2, we got the answer right here. This question, yeah. Now circuit is important for us. Circuit is important for us. Let us do it from the circuit. What is asking? At node B voltage. See, node B voltage, direct answer. This is point B. How much is there? 12 volts is there, but with upside minus, downside plus. So therefore, we can say directly VB is equal to minus 12 volts. Nothing to do here. Option is C. Option is C. VB is minus 12 volts. VB is minus 12 volts. Option is C. C for Chennai. Right? Direct question. This is also. Find the current IM in the given circuit. IM. This is IM. He mentioned. Sorry. This is IM. He mentioned. This is 5 amperes. 5 amperes is coming this way. Yes. This current is minus IM. Okay, IM is this, minus IM will be opposite. 5 amperes is coming here. Apply current division. Minus IM is equal to current division, total current into, I want current in 40 amperes, 40 ohms, sorry. Then opposite impedance is 10 divided by 50. Minus IM is equal to 5 tenths, it is 1 ampere. So IM is equal to what? Minus 1 ampere. IM is equal to minus 1 ampere. Option is B. Option is B. B for Bombay. Option is B. B for Bombay. Right. Next question. Find the current I in the given circuit. 40 volts source, 200 ohms. Okay, circuit is important for us. He is asking for this current. Now tell me, 150 plus 600, 750. 750 in parallel with 500. How much is 750 in parallel with 500? That is 750 into 500 divided by 750 plus 500. How much is 7 plus 3? 1000. 1250. 1250. 0, 0 gone. So 750 into 50 by 125. 25 2s, 25 5s, 5 1s. Okay, 5 5s. How much it is? 300 ohms. this is 300, this total is 300, 300, this total is 300, that is in series with 200, total is 500. This current IT, what is IT? Total current IT is equal to 40 divided by 200 plus 300, 500, right? But I want this small current I is equal to IT into, yes, current division. This current is IT, so opposite the resistance 500 divided by total 500 plus what is this 750. Now let us do this calculation. What is IT? I am using this space. IT is equal to how much? 40 divided by 500 into 500 divided by, yes, 500 plus 750, 1250, these two gone, this is gone. 4 divided by 125. How much is 4 divided by 125? You just calculate and tell me. I'm using my cell phone calculator for doing that calculation. Yes, 4 divided by 125, 0.032 means this is 0.032, simply 32 milliamperes. Option is C for Chennai, 32 milliamperes. Next question. Supernode is considered when there is dash between two nodes. If there is a voltage source, see, means whenever voltage source is there, we can't write KCL means voltage difference divided by resistance. Why? Because voltage source resistance is 0. If there is a voltage source, yes, we will take that two nodes combinedly as supernode. Next, find Vm in the circuit. Okay, he's asking about Vm. Simply voltage division. Easy questions. Vm is equal to total voltage 8 into 25 divided by 100. 25 fours, 4 twos. So this is equal to 2 volts. Option is B for Bombay, 2 volts. Right. Next question. In a series RLC, in a series RLC resonance circuit, at resonance the current drawn by the circuit is maximum. So you see how many times the resonance questions are repeated. That much important is series resonance, parallel resonance, about impedance, about current, these things, and resonant frequency. Okay, upper cutoff frequency, lower cutoff frequency is given. Then what is resonant frequency? Then after that quality factor. Right, very important things for your exam. Next, two inductors having self-inductance 1 Henry are connected in parallel such a way that their fluxes act in the same direction. If the mutual inductance is 0.5, yes, then find the equivalent inductance. You see, he given two inductances which are connected in parallel. Right? And there is a mutual inductance M also. Right? Yes or not? Then he is asking about the equivalent inductance. If two inductance are in parallel and he is saying both the fluxes act in the same direction, the formula for L equivalent is L1 L2 minus M square by L1 plus L2 minus 2M. Okay, yes, L1 L equivalent is equal to L1 L2 minus M square by L1 plus L2 minus 2M. 1 into 1 minus M square, 0.5 square, 1 by 4 by 1 plus 1 minus 2 into 0.5. 1 minus 1 by 4, 0.75. 2 minus 1. This is answer is 0.75 Henry. Answer is what? 0.75 Henry. Damn easy question, 0.75 Henry. Next question. If a circuit load impedance is 25 minus J25, power factor. I told you in the previous discussion itself, power factor is equal to resistance by magnitude of the Z, which is also equal to P by mod S. So from resistance by mod Z, what is resistance? 25 mod Z root of 25 square plus 25 square. 2 into 25 square. So 25 gone. 1 by root 2, that is equal to 0.707. And the nature is leading in nature. Why? Because minus is there. Minus means it is a capacitive in nature. That is capacitive in nature, 0.707. Next. A series RLC circuit is in resonance when XL is equal to XC. Either series RLC or parallel RLC, XL is equal to XC is the condition for both series and parallel RLC, yes, for both series and parallel RLC, XL must be equal to XC. Next question please. The inductive reactance of an inductor depends upon XL is equal to omega L, omega is equal to 2 pi FL. It depends upon frequency and inductance value. Yes, frequency and inductance. Option is D. Frequency and inductance. Option is what? D. D for Delhi. Next question. Which of the following circuit elements can store energy and return it to the circuit? Capacitor, inductor. L and C are energy storage elements which can store and return back to the circuit. Yes. Capacitor and inductor only. Yes. Resistor only. Resistor can never store, it always dissipates. Capacitor only, inductor only. No, both. Capacitor and inductor. Right? Next question. Resistors 2 ohms, 4 ohms, 6 ohms are connected in series. Okay. The total current flowing through the circuit with the 24 volts DC supply is 2, 4, 6. This way connected 2, 4, 6. How much is this? This is 24. 6 plus 6. 2, 4, 6. This total is 12. Okay. This is current I. I is equal to 24 divided by 12, that is 2 amperes. How much it is? 2 amperes, right? Option is C. Right? Next question. In an RC circuit, the time constant is given by tau is equal to RC for both, for R equivalent into C equivalent for any RC circuit. Okay, and units are seconds. Tau is equal to L equivalent by R equivalent for any RL network. For any RL network, its units are also seconds. R into C. Option is A. Next question. The real power P in an AC circuit is given by, most of the times we saw P is equal to VI cos phi, Q is equal to what? VI sin phi. Right? Number of times we saw this. Phi or theta, whatever it is, P is equal to VI cos phi or cos theta. Cos should be there, right? Next, in an AC circuit, the power factor is 0.6 lagging. If the active power consumed is 600, what is the apparent power? S is equal to P plus JQ. Let's make a triangle. This is P, this is Q, this is phi, this is S. Now tell me, he given P, he is asking S. P and S connection cos phi. Let's write cos phi. Cos phi is equal to what? Adjacent side by hypotenuse. S is equal to P by cos phi. Or P is equal to S cos phi. P is equal to what? S cos phi. But I want S value here. P is how much given? P is how much? 600 divided by cos phi is 0.6. 6000 divided by 6. How much it is? 1000 VA. Option is A. Right? A for apple. Right? Let's go for the next question. A circuit has a lagging power factor. To improve the power factor, which of the following devices should be connected and how does it affect the current drawn? See, to improve the capacitor, this question actually I thought of keeping in power system, but in networks also we can easily understand. To improve the power factor, we use a shunt capacitor, okay, and it is going to reduce the current drawn from the source. Okay, resistor, no. Capacitor in parallel reduces the current and improves the power factor. Option is B. To improve the power factor, any capacitor must be connected in parallel or in shunt to the load, and it will reduce the amount of current that is drawn from the source. Option is B. Next question. In a balanced star connected three-phase system, the line voltage is 400. What is the approximate phase voltage? Star connected. In star connection, in star, phase voltage is equal to line voltage by root 3. That's all. 400 divided by root 3. Approximately 230 volts, I guess 230 volts. Or just let me do with the cell phone calculator. Yes, just a minute please. 400 divided by 1.732. Yes, it is 230. Absolutely, it is 230 volts. Right? Next question. Yeah. See, with this we are done with 60 questions from power system PYQs as well as practice questions for HPCL Electrical Officer CBT preparation. We covered all the topics starting from DC analysis, Ohm's law, KVL, KCL, nodal, mesh, what is node, what is mesh, everything we covered in networks, right? If you have any queries with respect to your preparation, you can contact us using the number that is mentioned in the description box. Thank you.
Welcome to everyone. Today we will discuss previous year questions and most expected MCQs, and here we discussed two subjects. First one is power electronics and second one is EMFT, that is electromagnetic field and theory. So first question number 1. In a single phase half bridge controlled rectifier, this is the key points. Controlled rectifier means this rectifier is made by using SCR, okay, and this is the single phase and half bridge. Increasing firing angle from 0 to 90 degree cause the output voltage to stay constant, become negative, decrease, increase. Yes, decrease. So this is the right answer. And what is the relevant information? See, in a controlled rectifier, the firing angle alpha determines when the thyristor starts conducting. As firing angle increases from 0 to 90 degree, conduction begins later in each cycle. This reduces the average output voltage because a smaller portion of AC waveform is utilized. This is the waveform of circuit diagram relevant rectifier. Next, question number 1. In a 3-phase 6 pulse, this is important, 6 pulse uncontrolled rectifier, what is the approximate value of ripple frequency in the output of DC voltage if supply frequency is this? See, what is the formula? Okay, output frequency is given as N into Fs. Fs is the supply frequency or input frequency, and here N is the number of pulse. In this rectifier, how many pulses are used? 6. So we use 6 pulses. What is the input frequency or supply frequency? 50 hertz. 50 hertz. This is the 300 hertz. This is the right answer. So B is the right answer. Here we use all the relevant information. Okay. Next. In a basic series inverter circuit, what is the expression for the damping factor? R by 2 under root C by L, R by L, L by 2R, L by R. So A is the right answer. Okay. This is related to basic series inverter. A basic series inverter circuit behaves like an RLC series circuit. The damping factor zeta for an RLC circuit, series circuit, is given by R by 2 under root L C by L. It determines whether the response is underdamped, critically damped, or overdamped. Hence, the correct expression for the damping factor is R by 2 C. What is the condition for overdamped? We write here, for overdamped response, zeta is greater than 1. Okay guys, next, for underdamped, this is we discussed in control system also. For underdamped response, zeta less than 1. Okay, next for critical damp, for critically damped system or response, both are same things. Damped response, zeta is equal to 1. Okay, zeta equal to 1. Zeta is the damping factor. Okay, damping, or we can say damping ratio. Next, what is the maximum conduction angle of a thyristor in a 3-phase semi-controlled bridge rectifier operating in continuous conduction mode? Okay, so A is the right answer. Okay, in a 3-phase semi-controlled bridge rectifier, each thyristor conducts for a fixed interval in continuous conduction mode. Due to the 120-degree phase displacement between the 3 phase, each device conducts for 120 degree. At any instant, two devices, one from the positive group and one from the negative group, conduct. Okay, this is the circuit diagram of this circuit. Next, what happens to the output voltage in step down chopper when the duty cycle is increased? What happens output step down chopper? So for step down chopper, output voltage VO equal to dVs. Step down chopper we also known as buck converter. Okay, and what is the meaning of step down? If output voltage is less than the input voltage, then this is acts as a step down chopper or buck converter. Okay, this is the question related to buck converter or step down chopper. So what is the question? In step down chopper, when the duty cycle is increased, duty cycle if increased, then output voltage is also increased. Na output voltage increase, yes, is the right answer. Okay, this is the explanation. This is the all the points which are be discussed in the theoretical discussion. Okay, next. What is the maximum conduction angle of a thyristor in a three-phase fully controlled bridge rectifier? Tell me. Yes, this is the right answer. In a three-phase fully controlled bridge rectifier, each thyristor conducts for a fixed duration. Due to the 120-degree phase difference between the three supply phases, conduction shifts from one thyristor to another every 60 degrees. Each thyristor remains on for 120 degrees before being turned off by natural commutation. What is the commutation? Commutation is the process related to turn off the SCR. Okay, turn off the SCR. Next, in a single phase parallel inverter, this is related to parallel inverter. What is the primary function of the inductor L? Tell me. What is the, yes, to make the source current constant, primary function of the inductor, because inductor can't allow sudden change of current. That is why for parallel inverter, what is the primary function of inductor? To make the source current constant at the load. So A is the right answer. In a single phase parallel inverter, the inductor is connected in series with the DC source. Its main role is to maintain a nearly constant current from the source. It stores energy when current increases and releases it when current decreases. Okay, this is the circuit diagram respect to parallel type inverter. Okay, next question, question number 8. What is the shape of the input current waveform of a single phase? This is the important single phase and full bridge controlled rectifier supplying highly inductive load. Highly inductive load. Option number A, DC. B option square, triangular, sinusoid. Yes, B is the right answer. Square wave. This is the very important question related to fully controlled rectifier. Okay. Next, this is the all about explanation. Highly inductive load current remain nearly constant because for highly inductive load, see, inductor can't allow sudden change of current. That is why when we use highly inductive load, then load current remain constant, and or we can say it follow the source current, and source current is a square wave. That is why load current is also a square wave. Okay, if we write Fourier series for that, 4I naught upon n pi sine n omega naught t minus n alpha, but this is not required here, so we not write here. Next, question number 9. In harmonic reduction using transformer connections, what is the essential condition for achieving a net output voltage with reduced harmonic content? Different frequency output from each inverter connected without any transformer. This is in logical option. Each inverter operating at different voltage level. Okay. Next, similar voltage waveform but with phase shift between them. This is the right answer. Okay. This is the right answer. Next, which factor most significantly affects whether a chopper operates in continuous conduction mode? Tell me, what is the answer? Next, see, gate triggering pulse width, switching frequency, load inductance. Yes, this is the right answer. Load inductance. What is the explanation? Continuous conduction mode, CCM means continuous conduction mode, occurs when the current never falls to zero. See, this is the waveform. if this waveform does not break in one time period or for a finite period of time, then this is the continuous. If we draw other graph, this is graph, but this graph is break in this region, then this is continuous now. So this is the meaning of continuous and discontinuous mode. Okay, continuous conduction mode occurs when the load current or current never falls to zero, like this. This is the continuous and this is the discontinuous. Okay, so load inductance is the right answer. Next question. In a series inverter, tell me answer. In a series inverter, which configuration is mostly used to overcome the drawback of intermittent power flow? Intermittent power flow, okay. Option number A, parallel inverter, full bridge series inverter, half bridge, yes, this is the right answer, half bridge series inverter, okay. Half bridge series inverter, this is the basic points and this is the diagram, okay. Half bridge VSI. If here we use full bridge VSI, then full bridge VSI contain two half bridge VSI, okay. We use here VSY2 and like here we use 4 switches, but in full wave VSI we use 8 switches, okay. Power also becomes 4 times because voltage magnitude becomes 2 times and power, it depends on the voltage square, that is why power becomes 4 times. Next, which of the following best describes series inverter in terms of their commutation technique? Current source inverter, voltage source inverter, forced commutated inverter, self-commutated inverter. Yes, self-commutated inverter is the right answer. This is the diagram of self-commutated inverter. Next, a chopper operates switching frequency this. Switching frequency 1 kilohertz. So first of all, we write frequency in hertz. 1 kilohertz means 10 to the power 3 hertz. Okay. Duty cycle 0.4. D equal to 0.4. In certain book, duty cycle represented by symbol alpha. But in our course or here we show the duty cycle by the symbol capital D. Okay. Next, what is the on time of the switch? So in a chopper, okay, switching frequency is given. So with the help of switching frequency, we can determine the time period. 1 upon frequency is the time period. So we find the time period like that. Switching frequency T equal to 1 upon frequency, that is 1 upon 10 to the power 3, that is 1 millisecond. And duty cycle equal to T on upon T. Here T on equal to dt, D is the 0.4 and T is the 1 millisecond. So 0.4 millisecond. Hence on time of the switch is 0.4 millisecond. So this is the very simple and this is the PYQ of your previous examination. Okay. Next, this is the circuit diagram of relevant converter or chopper. Next, in a single phase 2 pulse, this is the important. In rectifier, this single phase or 2 pulse converter operate with firing angle alpha equal to 60 degree and a distortion factor 0.8. Calculate the input power factor. So what is the input power factor? Here this is the operate with a firing angle. Okay, calculate the input power factor. Input power factor equal to GF. Okay, this is not the girlfriend. Okay, G4 distortion factor, that is 0.8 and F is the firing angle. Okay, firing angle, here we write this alpha or GF and F is the fundamental displacement factor, that is cos alpha. Alpha is the 60 degree, cos 60 is the 0.5 and 0.5 into 0.8. What is the answer? 0.4 is the right answer. This is the right answer. Okay, input power, this is the relation between the input power factor and the fundamental displacement factor, or we can say displacement factor. Okay, we write here input power factor equal to G means distortion factor, F is the fundamental displacement factor, that is cos alpha. Okay, next 15 question, tell me answer. Yes, when the comparator output high in sinusoidal pulse modulation, sin M, when the reference signal has magnitude lower than the carrier signal, when the reference signal has magnitude equal to the carrier signal, when the reference signal has magnitude higher than the, yes, when reference signal has magnitude higher than the carrier signal, then this is the sinusoid pulse condition. Okay, see, when is the comparator output is high? Yes, when the reference signal has magnitude higher than the carrier signal. This is the explanation in SPW. That is single pulse sinusoid. See, here we use what is the SPWM, that is sinusoidal pulse width modulation, and here we use single pulse. Next, a single phase full bridge inverter has resistive load, okay, means R is given 100 ohm, DC voltage 100 volt. Calculate the peak inverse voltage of SCR. Tell me, 100 volt, 80 volt, okay, 200 volt, 110 volt. Yes, this is the peak inverse voltage. Okay, what is the meaning of peak inverse voltage? In the reverse bias condition, the maximum voltage appears across the device is said to be peak inverse voltage. In a single phase full bridge inverter, each SCR must block the full DC supply voltage when it is in the off state. The peak inverse voltage across each SCR is equal to the DC input voltage. DC voltage 100, that is PIB of SCR is 100 volt. Next, what is the output voltage of a single phase half bridge and full bridge inverter? In half bridge, VDC by 2 or VS by 2. Okay, this is not the correct. And in the full bridge, VS. So VS only in this option. So B is the right answer. Formula based question. Next, what is the value of minimum steady state output current in step down chopper? When Vs equal to this and chopper connected to RLE load, R, E and L is given, and the total chopping time, okay, on time is this. Total time given and on time given. Here we easily find the duty cycle, T on upon total time. So Vs equal to this, R equal to this, E equal to L equal to T and T on. So first of all, we determine the T on upon T, that is the duty cycle, 0.3. During on time, current rises. During off time, it decays through the load. Yes. In a steady state RLE load, minimum current is obtained considering exponential decay and rise over one cycle. Solving using chopper current equation give minimum current 51.4 because exponential current is involved. So this is lots of calculation are involved. So you leave it. This is question rarely asked in the question. Okay, 51 point. This is the right answer. Here we use the transient equation. Okay, and for transient equation, calculator must be better available, but in your examination calculator not allowed. So this question is not calculated by handy calculation because exponential terms are involved. See, in the modified MC Murray half bridge inverter, the value of resistance which provides damping RD VCL 2LC. Yes, 2LC is the right answer. Okay, 2LC is the right answer. This is the circuit arrangement. Tell me, this is the answer. Next, in which method of control of AC output, the method does not produce harmonics at low output voltage level? Okay, pulse width modulation, AC voltage control, DC output control, multiple pulse modulation. Yes, AC voltage control. AC voltage control. This is the key points related to AC control. AC voltage control. During which time period does the load current flow from source side in series inverter? Negative cycle, positive cycle? Yes, positive cycle, because in negative cycle current power flow from load to source. Okay, this is the meaning of power flow in the inverter circuit. Okay, next, for type A chopper with RLE load, okay, supply voltage this contains conduct. Calculate the load current for duty cycle. Load current means average current, and average current equal to, this is the RLE load, but type A chopper means buck converter. So in buck converter, output voltage VO equal to DVS and output current VO by R. Okay, see here beta, output voltage VO equal to DVS, D is 0.3, 0.3 is given, 0.3 duty cycle. Okay, and Vs is the 220, Vs is the 220. So here we get the output voltage, and RLE load VO equal to IR plus E. Here we substitute the VO 66, I into 1, that is the R value of R equal to 1 here, okay, and E equal to 24. Here we get the I equal to 42 ampere. So this is the right answer. Simple question. Next, modulation index M is defined as a summation of the amplitude of rectangular reference signal and amplitude of triangular carrier wave. Next, the product of the amplitude of rectangular reference signal and the amplitude of triangular carrier wave. Okay. Next, the ratio of the amplitude of triangular carrier wave to the amplitude of rectangular reference signal, the ratio of the amplitude of rectangular reference signal to the amplitude of triangular carrier wave. Yes, this is the right answer. This is the simple definition of mathematically modulation index. A reference upon A carrier. Okay. Carrier. What is bipolar pulse width modulation? VPWM. Voltage switches between two level minus VD and VD. Two polar modulation. Voltage switched to or more level of voltage. Modulation on positive polar side. No. This is the right answer. Voltage switches between two level. This is the meaning of bipolar pulse width modulation. Simple forward question. This is the waveform relevant to this. What do you mean by the multi-phase chopper may be operated in phase operation mode? How a multi-phase chopper may be operated in phase operation mode? Okay. All the parallel connected chopper on and off at different times. All the parallel connected chopper are on and off at the same time. Yes, this is the right answer. All the parallel connected choppers are on and off at the same time. This is the meaning of multi-phase chopper. Next, what is the work of a large capacitor connected to a DC bus in a voltage source inverter? What is the purpose of large capacitor connected? It provides low impedance path on the high frequency component in a DC link current. It protects against thyristor failure. It makes a constant voltage DC link. It minimizes the current ripple during high frequency. So our answer is A is the right answer. It provides a low impedance path on the high frequency component. How at high frequency it offer low impedance? See, we define capacitive reactance XC. XC equal to 1 upon omega C. Omega is the 2 pi F. When F is the high, then Xc is the low. That is why we mark that option. It provides low impedance path on the high frequency component in a DC link current. Okay, this is the meaning of that question. C. How much time is the output power of full bridge inverter to a half bridge inverter? 4 times, yeah. 4 times, because power is proportional to V square, and in full bridge inverter, this is the question related to inverter. In full bridge inverter, output voltage becomes 2 times the voltage as compared to half bridge. When voltage becomes 2 times and power depends on the square of the voltage, then power becomes 4 times as compared to single phase half bridge inverter. Okay, this is the same explanation. Next, which type of waveform is given by DC chopper in input and output condition? In input continuous, but in output discontinuous. So this is the right answer. Okay guys, this is the simplest question here related to chopper circuit. Next, a step down DC chopper has a resistive load of R equal to 15 ohm and the input voltage EDC or VDC 200 volt. When the chopper remain on, its voltage drop 4.5. The chopper frequency is 2 kilohertz. The duty cycle is 50%. Determine the average output voltage. And this is the step down. C. In the step down chopper, output voltage equal to dVs. But when drop is 0, when drop is 0 across the chopper circuit. But when drop is considered, VO equal to D Vs minus drop. Okay, when drop is considered, when drop is considered, okay, is considered. So duty cycle equal to duty cycle is given, duty cycle 50%, that is 0.5 put here, and Vs equal to 200 and drop 4.5 put here and find the answer. See, effective on state voltage 200 minus 4.5, that is Vs minus drop. This is the, and duty cycle is equal to 50% means in decimal 0.5. Average output voltage dV on. V on means effective voltage, and effective we determine from this 200 minus 4.5, that is 195.5. Put it in this formula, we get 97.75. This is the very important question. If any student directly solve like that, VO equal to dVs, and what is the D? 0.5, and Vs is equal to 200, and 0 cancel, 100 volt na, and 100 volt is also mentioned in the question, no na. So if 100 volt is in option, then student mark that option, but care about this question because here voltage drop is given, so we cannot apply directly formula VO equal to dVs. First of all, we find the effective voltage, that is in the supply voltage we minus the drop. If drop is not given, then we consider ideal circuit, and in ideal circuit we consider drop across all the devices is 0. Next, 30th question, are designed to have both controlled turn on and turn off capability. Gate turn off thyristor, okay, fast switching thyristor, phase control thyristor, static induction thyristor. No, gate turn off. See, this is the question related to thyristor family, GTO. GTO, gate turn off thyristor. What is the basic difference between the GTO and SCR? That is conventional SCR, silicon control rectifier. See, SCR is a semi-controlled device. What is the meaning of semi-controlled? If we can control either on period or off period, then this type of device is said to be semi-controlled device. If we can control both the state, on or off state, then this type of device is said to be fully controlled. Okay, see, this is the question related to both control turn on and turn off capability. This is the GTO, because GTO, the turn on process of GTO is same as the SCR, but turn off process is totally different. GTO is turned off with the help of gate pulse, but SCR can't. Okay, this is the basic difference between the GTO and tell me. This is the basic difference of GTO and SCR. Okay, so that is why we put the option A, GTO. This is the all the points relevant to GTO. Next, in a half bridge inverter, what is the value of root mean square output voltage? Now, where Vs is the average voltage. Average voltage. Tell me, half bridge inverter, what is the root mean square voltage? Simple question here. Root mean square voltage. In a half bridge inverter, what is the value of root mean RMS output voltage? Yes, Vs by 2. Okay, Vs by 2. If this is the full bridge inverter, then what is the RMS output voltage? Vs. Okay, Vs. Next. Next, a step-up chopper is used to deliver load voltage of 400 volt from 200 volt DC source. If the blocking period of the thyristor is 80 microsecond, compute the required pulse width. Okay, so this question is related to chopper circuit, and deliver the load voltage, that is the, this is the output voltage and this is the input voltage. Output voltage is more than the input voltage, so this is question related to boost converter. Okay, boost converter. For a step up, boost converter VO equal to VS over 1 minus D, VO equal to 400 given, VS equal to 200. So with the help of this formula, we can easily determine the duty cycle 0.5. Okay, duty cycle T on upon T and blocking time T off is given. So D equal to, here we place T total time equal to T on plus T off. This is the total time. So in place of T, we place T on plus T off. But duty cycle we determine from this formula 0.5 put here, and T off is also given 80, and we find the T on. Okay, T on. Okay, this is not the, okay, T, okay, now T off also 80. Okay, hence required pulse width is 80 microsecond. Pulse width means on period, for how many times this pulse is available. Okay, next. A chopper circuit is operating on TRC. What is the full form of TRC? Time ratio control. Time ratio control. What is the full form of TRC? Time ratio control. Okay, principal at a frequency of 80 Hz on a 20 volt DC supply. If the load voltage is 200 volt, compute the conduction period of thyristor in each cycle. This is also the simple question. See, here frequency is given and input voltage also given, and load voltage is given. Load voltage is greater than the input. That is why this is the question related to boost converter. And in boost converter, if the load voltage is 200 volt and DC, this is the TRC. Okay, 1 minute. Chopper circuit operating TRC principle at a frequency of 80 Hz on 20 volt DC. The load voltage is 200 volt. Okay, compute the conduction period. The solution is the wrong here. We mark the correct solution because here formula is the buck converter, which is the wrong. See, here output voltage given 200 volt. Okay, this is the load voltage, or we can say output voltage, comma in volt DC, that is the VS. VS equal to 20 volt and frequency equal to 80 Hz. So for boost converter, why we use the boost converter formula? Because load voltage, that is output voltage, is greater than the input voltage. That is why we use the step up chopper circuit formula. Okay, see, output voltage equal to Vs over 1 minus D. Okay, 1 minus D. VO is given 200. 200 equal to Vs equal to 20 over 1 minus D. So 1 minus D equal to 20 upon 200. That is 0 cancel. Okay, 0.1 and D 0.9 आ जाएगा. Okay, D equal to 0.9. See, 200. Okay, 0.1. This is the 0.1 and 0.9. Okay. So compute the conduction period. Next, D equal to T on upon T, and D is the 0.9 na. We calculate here. D equal to 0.9 equal to T on, we can find. Okay, T, but 1 upon T is the chopping frequency, and given in the question, into chopping frequency, and T on 1 minute, T on we find. Okay, so first of all, T on equal to TD, and T is the 1 upon frequency, time period, and D, what is the 1 upon frequency? 1 upon 80 into D. D is the 0.9. So we easily determine the on period like that. Okay, when you solve this expression, you easily determine the on period. But this solution is not. This solution is wrong, because this formula VO equal to dBs we apply for the buck converter. Buck converter means step down chopper, means output voltage less than the input voltage. Okay, input voltage. Next, which of the following statement is true about the thyristor? A thyristor is 4-layer semiconductor device of PNPN structure with 3 p.n. junction. Yes, it has 3 terminals, anode, cathode and gate. Both statements are true. Okay, only one, only three, or neither one or both statements are true. Okay, both statements are true. This is the explanation. PN. Okay, this is the 4-layer semiconductor device and 3 terminal, anode, cathode and gate. Gate are the controlling terminal. Gate are the controlling terminal. Next, choose the correct pair. Okay, power MOSFET, it is a voltage control device and require only a small input current. IGBT, there is no second breakdown problem as with BJT. Both statements are correct. Only one, neither one or third. Okay, only third. Both statements are correct. Okay, power MOSFET, IGBT contain both the contribute of both the contribution of means both the combined attributes of power MOSFET and power BJT. This is the biggest advantage of IGBT. Next, assertion region. Okay, 36 question number, assertion, and this is the reason of that assertion. Okay, in IGBT, first of all we read, okay, assertion. In IGBT combines the advantage of BJT and MOSFET. This is the very important line. Okay, this is the right. And IGBT has high input impedance like MOSFET and low on-state conduction losses like BJT. Both statements are correct. Both A and R are true, and R is the correct explanation of A. Yes, B is the right answer. Next, a chopper circuit is operating on TRC principle at a frequency of 2 Hz on a 220 volt DC supply. If the load voltage is this is also load voltage is less than the input now. That is why this is the buck converter. So here we apply VO equal to dBs, and by using VO equal to dBs, we easily determine the duty cycle. Okay. So first of all, frequency is given. Chopping period T equal to 1 upon frequency, 1 upon 2 equal to 0.5 second. In TRC means time ratio control. The total cycle time is determined by the switching frequency. Yes, the given frequency directly define the period of operation. Hence, the chopping period in each cycle is 0.5. Okay, here compute the chopping period. Yes, period. This is the simplest question here. This is the answer. Only chopping period is asked. Which of the following pair is correct? Single pulse width modulation. Single pulse width modulation control. There is only one pulse per half cycle and the width of the pulse is varied to control the inverter output voltage. The next option, multiple pulse width modulation. The harmonic content can be reduced by using several pulses in each half cycle of the output voltage. Only second is correct, both 1 and 2, neither 1 or 2, only 1. Yes, both 1 and 2 are correct. Correct. This is the explanation given here. Which of the following statement is correct about the IGBT? Very, very important question. The switching speed of IGBT is inferior to that of MOSFET. Okay. IGBT are finding increasing application in the medium power applications such as DC and AC motor drives, power supplies, solid state relays and contactors. Both 1 and 2. Okay, neither 1 or 2, only 1, only second. Okay, yes, both 1 and 2 are correct. This is the basic application based questions and very simple. If you easily crack this question, then you are comfortable in the actual examination also, because here we consider all the expected questions and previous year questions related to power electronics. After power electronics question, we discuss the MFT question, and very basic questions from the MFT is asked. Okay, next. Which of the following is correct about power MOSFET? The switching speed is very high and the switching times are of the order of nanoseconds. Yes, this is the right. Power MOSFET find increasing application in low power high frequency converter. Okay, yes, both are the correct. Okay, because this is the majority carrier device here. In a 110 volt DC chopper drive using a CLC scheme, the maximum possible value of accelerating current is 200 ampere. The lower limit of the current pulsation is 140 ampere. The on and off periods are this and this respectively. Calculate the chopping frequency. Simple question here. Total time period T on plus T off, 15 millisecond is on period here mentioned. Okay, and off period is 12 milliseconds. Then total time period is the 27 millisecond. Converted into second, 10 to the power minus 3. Put here chopping frequency 1 upon T, 37. Okay, so that is why 37 is given in the option. 37 is not given. Answer is 27. Based on the given option, the closest answer is 27. Okay, based on the given option. Next. For obtaining load commutation in voltage source inverter, capacitive reactance of load must be its inductive reactance. Okay, less than, greater than, independent, equal to. Yes, greater than. Okay, obtaining the load commutation. Capacitive reactance is inductive reactance. Yes, greater than. Okay, this is the explanation. This ensure current leads the voltage. This is the simple phenomena also discussed in the network analysis in resonant circuit, in which if X is greater than XL, then circuit behave as a capacitive or leading, means current leads the voltage. If XL equal to XC, then this is the condition of resonance, means circuit behave as a purely resistive. If XL is greater than XC, then circuit behave as a purely inductive, or we can say inductive, not the purely but inductive, means current lags the voltage. Next, an average responding voltmeter is reliable for measuring which type of AC waveform: pulse DC signal, distorted waveform, pure sine. Yes, pure sine wave. Yeah, pure sine wave. This is the desirable, na? And this is the related to your measurement. This is not the question of power electronics actually. In a single phase half wave circuit with RL load and free wheel diode conduct only when SCR is reverse bias, SCR is forward bias and conducting. Supply voltage is positive, SCR is forward bias. No, SCR is reverse bias. Means this freewheeling diode provide free wheel path for the load current when the reactive element discharge. Okay, this is the correct explanation. See, the average load voltage in buck chopper or buck converter is given as, where alpha is the duty cycle of chopper and VO is the output voltage, V is the supply voltage. Simple formula. Yeah. We already tell this concept. What is the concept? In some book or in some standard, duty cycle is expressed by the symbol of alpha or K also. So here especially mention alpha is the duty cycle. So VO equal to dBs. dBs and D is the here alpha. So alpha Bs. So VO equal to alpha Vs. Yes, C is the right answer. But in case of boost converter, average output voltage VO equal to Vs over 1 minus D. This is the final formula. And for buck boost, dBs over 1 minus D is the average output voltage formula. Okay. See, we write here for buck converter. For buck converter, VO equal to dBs, or we can say D is the alphas in some book, alpha Bs. For boost converter, VO equal to Vs over 1 minus D. Okay, or Vs over 1 minus alpha. For buck boost converter, VO equal to dVs over 1 minus D, alpha Vs over 1 minus alpha. This is the three formulas. Okay, and we also write here some other formula also. Alpha or duty cycle equal to T on upon T. Okay, and T equal to 1 upon chopping frequency, and on period in terms of duty cycle dt. Okay, here T on equal to T into D na, or we can say alpha T, because D is alpha also, and off period in terms of duty cycle total time minus T on, total time T and T on equal to dt. So take common T, 1 minus alpha, or we can say 1 minus D na here, 1 minus D or T 1 minus alpha, both are same thing, yeah, in terms of D and duty cycle. Here we explain all the relevant formulas na. In single phase capacitor commutative current source inverter with R load, the number of thyristor used are 6, 2, 8, 4. Yes, right answer is 4. Right? Yes, this is the simplest question. When we study the commutation process, because commutation process is related to turn off the SCR. Okay, this is the question related to commutation process. In a type A chopper, limit of continuous conduction is raised when given IMN is initial value of current, I max is the final value of current. Okay, continuous conduction is raised. IMN reached infinitely. Okay, IMN means minimum current goes to 0. I max reached to infinitely. I max goes to 0. Yes, B. I minimum goes to 0. Okay, 1 minute. Continuous conduction means current I minimum 0. Yes, becomes 0. Minimum current just touch the 0. Okay, not for finite duration of time it becomes 0. Just touch the 0 like that. Okay, this is also the continuous conduction mode. Type E chopper operates in first quadrant, first and second and four all quadrant. Yes, yeah. This is the basic diagram of type E chopper. Okay, this is the VO and this is the IO. All the four quadrant operation are possible in type E chopper. Okay. In the first quadrant, VO and IO both are positive. In the second quadrant, VO is positive but I is negative. In third quadrant, VO is negative and IO is also negative. In the fourth quadrant, VO is negative but IO is positive. Same as quadrant operation. Okay, guys? Next. Which of the following semiconductor device does not belong to the thyristor family? Programmable unijunction transistor, thyristor family. Okay. Silicon unilateral switch. Okay. Light activated thyristor, that is LASCR. Okay. Insulated gate bipolar transistor, that is IGBT. Insulated gate bipolar transistor. Yes, this is the right answer. Okay. This is the family of SCR, or we can say family of thyristor. Okay, SCR, triad, diode, LASCR means light activated SCR, that is light activated silicon controlled rectifier. SUS and PUH also the family of thyristor. Okay, but IGBT is a transistor family, that is voltage controlled device, not a thyristor. Next, what will be the output voltage frequency in a single phase full wave bridge converter? Same as input, this is the output voltage frequency in a single phase full bridge. This is the very standard question, same as the input supply frequency 0, twice the input. Yes, twice the input, yeah, because in the full bridge we like that output na, this, and input is like that. Input is this in one complete cycle. So this input repeat itself after this time period, but this waveform repeat from this time. So time interval becomes the half, or we can say time period becomes half for full wave rectifier, because this is the full wave bridge converter or simple full wave rectifier. Okay, both are the same things. Okay, in terms of this question, output frequency related. So here time period becomes half, that is why frequency becomes double. If this is the question related to half bridge inverter, then output frequency remain the same as the input frequency. Next, in a single phase full wave midpoint converter, the commutation is usually employed line impulse, resonant pulse, load, okay, line, yes, line commutation. This is the very simple question here, in which the polarity of E is reverses in line commutated inverter. In a single phase semi converter, for continuous conduction, freewheeling diode conducts for a firing angle alpha is pi minus alpha, pi plus alpha, alpha pi. Yes, alpha. Simplest question here. A single phase full converter bridge has single phase full converter. Full converter, and this is the bridge here, SCR 2, 8, 4 and 1. Yes, 4 is the right answer. And this is the single phase half bridge converter, then 2. C is the right answer. Modified MC Murray half bridge inverter is a commutative. Commutative, fill in the blank, voltage source. Okay, voltage source. Sorry, voltage, current. Okay, current, voltage, 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 current, current. Yes, this is the right answer. Current, voltage. Modified MC Murray half bridge inverter is a current commutated voltage source inverter. Yes. This is an application based question here. Identify whether the given statement related to choppers are true or false. This is the question related to chopper circuit. See, class A chopper is a step up or step down chopper. Saturable reactor is used in Morgan's chopper. So, A, first is false, second is true, one false, second is true, okay? One false, second is false, B option, and C, one true, and second is true, one true, and two is false. Class A chopper is yes, this is the step up, step down, no, beta, this is the wrong. Saturable reactor is using Morgan chopper, yes, this is the right, is the right answer. Okay, okay, this is the classification of your chopper circuit, simple question. Next, which of the following statements related to basic series inverter is incorrect? Only one SCR is required for entire operation. Ratings of commutating components are higher as compared to parallel inverter. The size of commutating components is higher as compared to parallel inverter. Commutating components are connected in series with the load. So A is the right answer. Only one SCR is required for the entire operation. This is the wrong. But here we select the wrong option or incorrect. The peak reverse recovery current of power diode depends on peak inverse voltage, temperature, rate of current flow, and storage charges. Yes. Okay. Peak recovery current. Yes. This is the right answer. Yeah. And this is the formula. Next. Approximately 60 questions we take here. Okay. From the power electronics, PYQ and expected questions. Which of the following is a 3-layer 2-terminal device? 3-layer and 2-terminal triac, no, in triac 3 terminals are available. Okay, SCR in 3 terminal, GTO 3, power diode, 3-layer, yes, power diode is, yes, because this is the 3 terminal, this is also 3 terminal, this is also 3 terminal. Step up chopper is employed through a source. This is the source voltage operated at a duty cycle of this average output voltage. Step up means Vs over 1 minus dr. Okay. Vs over 1 minus d or 1 minus alpha. Vs is given 200, alpha 0.5, put here and get the result 400 volt. Yes, output voltage is greater than the input, that is why this is the step up na, and I also here mention step up, that is why we use this formula. Next, what is the full form of RBSOA with reference to IGBT? Yes, reverse bias safe operating area. So D is the right answer. This is the very simple question related to IGBT. Type C chopper is combination of chopper type B and type D. Type A and type B, type D and type A, type D and type E. Yes, type A and type B. B is the right answer. The transfer characteristics of IGBT is a plot of version and version. Emitter current, okay, this is the question related to IGBT characteristics, collector current and gate emitter voltage. Theoretical question and application based questions and characteristics. In all the power electronics, we only uh, prepare for the topic like application based MOSFET, where we use MOSFET symbol and basic characteristics. Okay, and this is the minority or majority carrier device, unicontrol or fully control. Okay, semi control or fully control, unidirectional or bidirectional. These type of questions are very important. And what is the differences between the various devices? For which power device is given symbol use? Symbol shows here, symbol is not mentioned, so leave it. In a single phase full converter for discontinuous load current and extinction angle beta greater than pi, each SCR conducts for if firing angle. This is question related to very simple beta minus alpha. Okay, because when we put inductor in the load, then conduction goes beyond the pi. Okay, and this beta is the extinction angle, means at the instant where the current becomes the zero. This is the angle. Okay, beta, simple. A power MOSFET is a controlled and carrier. A power MOSFET is a unipolar, bipolar. Okay, yes, bipolar. No, unipolar, na. Unipolar and carrier. Majority carrier or minority? Minority carrier, no, beta. Majority carrier. Unipolar, yes, B is the right answer. Okay. Unipolar means the device in which conduction takes place due to the electron and hole, only one type of charge carrier. This device is said to be unipolar. Like BJT, bipolar junction transistor. In BJT, conduction takes place due to both electron and holes. That is why the name bipolar. Okay, and minority and majority carrier device, when the PN junction is negligible or not present in the device in the path of the current flow, then this type of device are said to be majority carrier device, otherwise minority carrier device. So this is the majority carrier device. Next, a single phase full bridge inverter has DC voltage 230 volt. Find the RMS value of fundamental component of output voltage. So here this is the single phase full bridge na. So here we write the output voltage for nth harmonic. This is the n equal to 1. This is the for nth harmonic. N equal to 1, 3, 5 and so on. Okay. For Vs over n pi sine n omega naught t. This is the for nth harmonic output voltage. But here fundamental and this RMS. For fundamental put here V01 and RMS we put RMS. So n equal to put n equal to 1 because we can find the we want to find the fundamental peak value. First of all, put for Vs n in place of n 1 into pi. This is the peak value and we divided by root 2. This is the RMS. Put all the values for VDC or for Vs upon pi and root 2. This is the expression, and from this is this expression we put. Okay, so VDC is 230, and when we solve this formula 207 we get. Okay, this is the little bit difficult because most calculation are involved, na? So this is the but simplest question. When we study the Fourier series analysis, then this is the expression. If in this question single phase half bridge inverter is given, then what is the difference? Here we use 2Bs over n pi. Okay. Next, in electromagnetism, the curl. This is the question related to EMFT. Now, from this, we discuss all the questions for EMFT. EMFT questions. So, in electromagnetism, the curl of a vector field represent rotational tendency. Curl represent the rotational tendency. See, the divergence of the field at a point. Okay. Next, the strength of the field at infinity. Next, the circulation or swirling of the field at a point. Yes, this is the right answer. Rotational tendency or circulation, both are same thing. This is the all points related to curl. Next, two charges Q1 equal to 2 microcoulomb, okay, and Q2 equal to 3 microcoulomb are placed 0.5 meter apart in vacuum, okay. What is the magnitude of electrostatic force between them? Use Coulomb's law of constant K equal to 9 into 10 to the power 9 meter square per Coulomb square, okay, Newton meter square per Coulomb square. So what is the formula of Coulomb's law? F equal to K Q1 Q2 upon R square. K is the Coulomb's constant given 9 into 10 to the power 9. If not mentioned, we use by default this formula, okay. So Q1 and Q2, first of all, we convert into micro into coulomb by multiplying 10 to the power minus 6 like that. So F equal to 0.216 Newton. Okay, this is the right answer. Simplest formula here in question. Next, the force between two magnetic poles placed in a medium is directly proportional to square of the distance. No, this is the wrong. Next, independent of the distance. No. Inversely proportional to distance between them. No, this is also wrong. Inversely proportional to the square. Yes. This is the right answer. Actually, force formula is given. No. Here we write complete formula. F equal to mu naught upon 4 pi. Okay. Pole strength M1 and M2 upon R square. R is the distance between the M1 and M2. M1 and M2 are the strength of the pole. Okay. Magnetic force. So this is the right answer. Inversely proportional to distance between the poles. The magnetic field intensity H at the center of the circular conductor of radius R carrying the current I. Okay, see, the magnetic field at the center of the center of the circular conductor means ring. Okay, see, I equal to B equal to mu Ni Y2R. This is the formula, and B equal to mu H. So when we put in place of B mu H, mu cancel, then H equal to Ni upon 2R. Here we consider turns is 1, so I A upon 2R. R is the radius, I upon 2R. So what is the formula? I upon 2R. Yes, D is the right answer. Next. What does Coulomb's law states? Simplest question. Force is constant regardless of the distance. No. Force is inversely proportional to distance. No. Force is directly proportional to the sum of the charges. No. Force is directly proportional to product of charges and inversely proportional to square of distance. Yes. This is the right answer. This is the formula. Okay. This is the formula. Like charges repel to each other, unlike charges attract to each other. Okay, this is the meaning. Next, Fleming's left hand rule is primarily applied to find the direction of induced EMF in a stationary conductor, force on a Fleming left hand rule, force on a current carrying conductor in a magnetic field. Yes, this is the right answer, and this is the basic working principle of motor also. Next, if the curl of a vector field is 0, then the field is said to be curl is 0 means irrotational. Na? So, irrotational is the right answer because curl indicates the rotational tendency. According to Faraday's law, the direction of induced EMF in a closed circuit is such that it opposes the change in magnetic flux causing it. Okay, yes. This is the Lenz law, na? This is the Lenz law, and Lenz law based on the law of conservation of charge. A conductor carrying current is placed in a uniform magnetic field. Okay, if conductor length is doubled, then current is held half or held. What happened to the magnetic force on the conductor? Magnetic force F equal to IBL sin theta like that, and this magnetic field, see, magnetic conductor length doubled and current is held. Magnetic, so both are cancelled to each other, so force are remain unchanged. Okay, the force remain the same. Next, simple question here. Two coils are said to be mutual induction if 1 Henry, if current of 1 ampere is one coil produces flux linkage of 1 Weber in turn in the other coil. Okay, this is the right answer. Yeah, a current of 1 ampere per second in one coil produces 1 volt in the other coil. This is the mutual induction phenomena. What is the self induction and mutual induction phenomena? See, if current flowing in a coil induces EMF in the same coil, then this is said to be self induction. If current flowing in a coil induces EMF in the other coil, then this is said to be mutual induction. Okay, this is the phenomena of self-induction and mutual induction. Next, which of the following statements correctly describe the relationship between the magnetic field intensity H and magnetic flux density in the medium? Okay, density B. Option A, H and B are completely unrelated quantity in the electromagnetism. This is totally wrong. H measure the number of magnetic poles per unit volume. Okay, while B measure the electric flux. Next, C is always independent of the H is always independent of the material medium. Yes, while B remain the same in all the media. Okay, B represent the number of lines of force per unit area. H is proportional to B. Yes, this is the right answer. Yeah. Okay, because B equal to mu H na. Next, according to Ampere's circuital law, the line integral of the magnetic field B around a closed loop is proportional to the algebraic sum of current enclosed by the loop. Yes, this is the statement of Ampere's circuital law. See, according to Biot-Savart law, the magnitude of magnetic field intensity dB due to the differential element current carrying conductor is proportional to the square of the current. No, this is the wrong. Next, the current in differential length, because see, dB equal to mu upon 4 pi IDL sin theta upon R square. Okay, so A option, square of the current. No, this is the wrong. B option, the current and differential length ideal. This is the right. And the cosine of angle. No, sine of angle. Na, the current in differential length and the sine. Yes, this is the right answer. Yeah. And this is the formula. Yeah. This is also given, dB proportional to ideal sin theta upon R square. This is the simple question here. EMFT, the questions of EMFT in power electronics also very simple question asked in your examination. See, the magnetic field intensity H on the axis of the circular current carrying loop. The magnetic field intensity H on the axis of circular current carrying loop. Constant along the entire axis, minimum at the center, okay, and increase symmetrically along the axis. 0 at the center and increase symmetrically. Maximum at the center, yes, maximum at the center and decrease symmetrically along the axis. I upon 2R na, we discussed in the previous formula. I upon 2R is the magnetic field formula due to circular ring. So this is the explanation. According to Faraday's law of electromagnetic induction, which of the following statement best describes the magnitude of induced EMF in a circuit? It is directly proportional to the rate at which the flux linkage through the circuit change with time. Yes, this is the right. Yeah. What is the formula? A equal to minus n d phi by dt. So d phi by dt is the flux change, or we can say rate of change of flux linkage. The property of a coil due to which it opposes any increase or decrease of current or magnetic flux through it called mutual inductance, resistance, self-inductance and capacitance. Yes, self-inductance here. Okay, inductance or self-inductance can't allow sudden change of current. Okay, and in similar way, capacitor can't allow sudden change of voltage. Okay, means for sudden change of current, inductor behave as a friction. So in similar way, for sudden change of voltage, capacitance behave as a friction. Next, a single phase AC circuit has a voltage of this and current 10 ampere with a power factor of this. What is the active real power? This is the single phase now. So VI cos phi, VI and cos phi 0.8. Putting the formula, we get 18 40 answer. Next, for a finite length straight conductor carrying current I in the direction of the magnetic field intensity H at a point in a space. Okay, finite length straight conductor. Okay, readily outward from the conductor, normal to the plane containing the conductor and the point determined by the right hand rule. Yes, this is the right answer here. Okay, simple formula, ideal sin theta. Okay, next question. Try. Next. The electric flux density at point P caused by the uniform surface charge density rho s equal to this per meter microcoulomb per meter square on the plane x equal to 2 and having permittivity of 1 is. This is the little bit difficult because calculation is involved. D equal to rho s upon 2 n cap, putting all the value, then we get this answer. Simplest but little bit difficult because calculation are involved. An 89 microcoulomb point charge is located at the origin. Calculate the electric flux passing through the plane z equal to 3. So phi equal to q. And what is the electric flux passing through the closed surface charge and closed by the surface na? So here hence flux through one side of plane total charge divided by 2, so that is 44.5 microcoulomb. This is the question related to Gauss law in electrostatics. Okay, this is the Gauss law. A charge located at point P 4, 60 degree, 1 is said to be in coordinate system R. This is the rho. This is the R, not the C. Rho phi z na. Rho phi and z means this is the space, spherical, cylindrical and Cartesian. No, cylindrical coordinate system. Okay. If r phi theta means this is the spherical, but here only this is the beta rho phi z. This is the cylindrical coordinate system, standard coordinates. R theta z, or we can say rho phi z, both are the same things. See, which of the following is correct for the electric field created by long line of a charge at point away from the line? Okay, long line means infinitely long line we assume. Okay, electric field equal to 2 lambda over r 1 upon 4 pi epsilon naught. See, this is the formula we write here in simplest way. A equal to 1 upon 4 pi epsilon 2 lambda over r. Okay, lambda is the linear charge density. Okay, so 2 cancel, lambda upon 2 pi epsilon r, or we can say rho l. Here in the option rho l is same meaning as lambda. Okay, so rho l upon 2 pi r, 2 pi r. Yes, this is the right answer. Okay, rho l, both the option are correct na. Rho l upon 2 pi epsilon into 1 upon a rho l upon this. Yes, beta, both the answer is right na, because both are the same things. Find the field intensity at this if rho l equal to this along the z axis. Okay, this is question also related to previous formula. Rho l upon 2 pi epsilon naught r. Find the first of all rho, under root is 6 square plus 8 square 10, and a direction ar cap, vector a upon mode of vector. Okay, and putting all the formula in this formula, we get 10.78 ax plus 14 point something. So this is the A is the right answer. This is the calculation involved. Little bit difficult according to calculation, not the conceptual difficult. The electric flux density in free space, if the electric field intensity is given, means H given, and density means B equal to mu H, and in the free space mu equal to mu naught into H. Mu naught equal to 4 pi into 10 to the power minus 7, H equal to given 2, putting all the value. Okay, this is the electric flux. Okay, this is the magnetic flux actually. This is the magnetic flux density, but electric flux density D equal to epsilon naught E. In similar way, putting E and epsilon naught 8.85 into 10 to the power minus 12 farad per meter. Putting all the values, and we get 17.7. Formula wise question here. Okay, 17.78. So B is the right answer. Simplest formula wise question. The electric potential at a distance 3 centimeter from 2 nanocoulomb. Electric potential at a distance. Okay, electric potential means due to point charge, electric potential equal to 1 upon 4 pi epsilon naught if free space is given, if medium is not mentioned, and point charge upon distance. So This is the formula. Q is given 2 nanocoulomb. 2 nano means 2 into 10 to the power minus 9 upon R means distance. 3 centimeter means 0.03 meter. And we get the result 600 volt. So this is the right answer. Formula wise question here. Next, a thin ring of radius 5 cm is placed on plane z equal to 1 cm in such a way that its center is at 001 cm. If the ring carries 50 milliampere along A5, then what is the value of H at 00 minus 1 cm? So B is the right answer here, and solution is given here. Simplest formula here. Magnetic field on the axis of circular rope. This is the formula, putting all the given values. This is also the calculated question. If the cylindrical coordinate A equal to this, then what is the value of curl of A? And this is question in the in which coordinate? Cylindrical coordinate. So in cylindrical coordinate, curl formula is that, putting all the given value, and we get 0.5 z. That is the C answer. This is the you also remember the curl, divergence and gradient in different coordinate system, like in Cartesian coordinate system, spherical coordinate system and cylindrical coordinate system. Okay, coordinate system. Find the total charge in sphere if the radius of the sphere 2 cm and volume charge density. Total charge means total flux. Okay, this is question related to Gauss law. Total charge equal to integral rho v dv, putting dv equal to r square sin theta dr d theta d phi, because this is here we use the spherical coordinate system, putting all the given value, and we solve. Integrating gives q equal to this. Okay, so 11.17 coulomb is the right answer. A 30 microcoulomb point charge is located at the origin. The electric flux passing through the portion of the sphere r equal to 10 cm, which is bounded by theta equal to 0 and pi and phi equal to 0 and pi by 2 is. This is also the question related to Gauss law. Yeah? Simpler question. This is the explanation. You can easily crack it. Okay. Next, find the numerical value of the divergence del d at the point indicated if d equal to this. This question in the Cartesian coordinate system, then divergence formula is this, and we differentiate all the d with respect to x, that is the partial derivative with respect to x, y, z respectively, and this is all the formula, and we putting the all the coordinate system which are mentioned in the numerical. This, okay, this is the coordinate. So we get 7.5 coulomb per meter cube. Okay, this is the A is the right answer. How much force can be produced by a charge in electric field? F equal to Q into E. This is the force formula. So 4 into 2, that is the 8 Newton. So C is the right answer. Simplest question here. Next, 98th question. Which of the following statement is correct regarding divergence theorem? Divergence theorem. In electrostatic, it is also called Gauss law. The divergence theorem helps us in replacing a surface integral by a volume integral and vice versa. Yes, both are correct here. Divergence theorem relates the surface integral and volume integral. This is also important here. This is the surface integral. This is the volume integral. Okay. Important question. The insulating layer between the capacitor's plate is completely called dielectric, diode, okay, diamagnetic, bipolar. Dielectric na? Dielectric. 100 question. Which of the following statement is correct regarding the permittivity of medium in Coulomb's law? The permittivity of medium is also called dielectric constant. The permittivity of a medium epsilon equal to epsilon naught epsilon r, both are right here. So this is the 100 question from my side, and this is enough for your practice. Okay. If you face any difficulty, in any question, or you require detailed analysis or detailed solution of a particular concept or question, then you comment on the comment section. Okay guys, thank you.
Hi, this is Ravikant. Welcome to YourPedia Education. Today we will discuss PYQ of HPCL Officer exam, and we covered the subject machine and measurement of electrical engineering. First we discuss measurement question, after this we discuss machine question, and all these questions are comes in different years of a HPCL officer exam. So we see one by one. Question is, with the help of 4.5 is digit voltmeter, the largest possible reading is what? Here, digital voltmeter is 4.5 digit. We know here 4 is the full digit. 4 is full digit. Each digit so 0 to 9, 0 to 9, and half is this is half digit, or you may say fraction digit. Here this is half digit, and this shows, this is MSB. This is what? Most significant beat of reading. Half digit is most significant beat of the reading, and so 0 to 1. This shows 0 to 1. Here, if we find the range of the digital voltmeter, then here 4 is full digit and half is fraction digit. That means total number of digit measured by this instrument is 5. So if we write here, half is the MSP, that means first digit of the reading. So here minimum number of reading shows by this instrument is 0 and maximum is what? 1. Now 4 is full digit, and here we say minimum number of full digit is 0 and maximum number is 9. So here we take minimum number is 0 and maximum number is what? 9. So here what I see, minimum value of reading by this instrument is 0 and the maximum reading taken by this instrument is 19999. So if here question is largest possible reading is what? So here minimum reading is 0 and the maximum reading taken by this instrument is what? 19999. So the correct answer for this question is option C. You may find the largest reading of this instrument by using formula of n digit. For n digit digital voltmeter maximum reading is equal to 2 into 10 to power n minus 1 of minus 1. Here n is the total number of digit. N is what? N is total number of digit. Here 4 is the full digit and half is the fraction digit. So half is also a digit. So here total number of digit is what? Total number of digit is 5. So if you putting this, you get the maximum reading 2 into 10 to power 5 minus 1 into minus 1. Overall minus 1. When you simplify, you get 19999. So the reading or range of the instrument of this instrument is what? minimum 0 and maximum 19999. You can find either by using the basic concept or by using the formula. So here we see the correct answer for this question is option C. Now move to the next question. Next question is, which of the following types of instrument is used for standardization of polar type AC potentiometer? Polar type AC potentiometer is standardized by using polar type AC potentiometer is standardized by using those instruments which have correct measurement of RMS value. Here question is, which of the following type of instrument is used for standardization of polar AC potentiometer? The reference used for the standardization is true RMS instrument, and here the true RMS instrument is thermal instrument. So thermal instrument is used for the standardization of polar type AC potentiometer. So the correct answer for this question is option D. Next, a 1 milliampere ammeter has a resistance of 100 ohm. Calculate the shunt resistance required to convert it into a 1 ampere ammeter. Here the meter reading is what? 1 milliampere, and the internal resistance of the ammeter is 100. Here question is, how much amount of shunt resistance connected in this instrument that they capable to measure 1 ampere. So the current required to be measured by this instrument is 1 ampere. We know this is basic PMMC ammeter having internal resistance Rm, and the current to be measured by this instrument is Im, and the voltage drop is Vm. Here question is, need to measure current I equal to 1 ampere, how much amount of resistance connected across the meter? We know to extend range, connect RSH. So this is basic PMMC instrument, and the value of resistance required to connect is what? Current to be measured is equal to I, and I is what? Sum of meter current plus shunt resistance current. So here I is what? I equal to Im plus ISH. Question is, how much amount of resistance connected across the meter so that this instrument can capable to measure 1 ampere current? We know here RSH is what? RSH is equal to Rm upon M minus 1, where Rm is the internal resistance of the meter and M is the multiplying factor, and their value is what? M is the ratio of current to be measured upon meter current. Here current to be measured is what? 1 ampere, and this instrument measures 1 milliampere. So 1 by 1 milli means 10 to power minus 3. If you simplify, you get 1000. So here RSH is what? RSH is equal to Rm is the internal resistance, and their value is 100. So 100 upon 1000 minus 1. Here 1 is a very smallest number as compared to 1000. So here we approximate 100 upon 1000. By this you get their value comes to 0.1 ohm, nearby 0.1 ohm. So the correct answer for this question is what? 0.1, that means option B. Next. Calculate the sensitivity of 0 to 1 milliampere ammeter. You know, sensitivity of the instrument is equal to 1 by meter current or full scale deflection current of the instrument. Full scale deflection current of the instrument. Here this instrument measures current from 0 to 1 milliampere. That means here full scale deflection current is what? You may write here Im is the meter current, or you may write 1 upon If, full scale deflection current. Full scale deflection current. So here full scale deflection current is what? 1 milliampere. So 1 upon 1 into 10 to power minus 3. That means their value is what? 10 to power 3. 10 to power 3. And the unit of sensitivity is what? Unit of sensitivity is ohm per volt. Ohm per volt. So here value is given 1 kilo. You may write this 10 to power 3 is kilo. 1 kilo ohm per voltmeter. So the correct answer for this question is option D. Next, which of the following types of instrument is used only for AC measurement? Only for AC measurement. Here hot wire is used for both AC and DC. Hot wire instrument measures both AC and DC. Thermocouple type instrument, this is also measure both AC and DC. AC and DCs. PMMC type instrument only measures DC. This is induction type instrument, and induction type instrument is a energy meter. Energy meter, and this instrument is only used for AC measurement. This is only used for AC measurement. So here AC measurement instrument is what? Induction type. Next, PMMC instrument can be used as a DC voltmeter without series resistance in the range of. When we using basic PMMC instrument for the measurement of voltage or current, the range of measurement for current is equal to 50 milliampere and the voltage is 100 millivolt. Without using the extension, we know to extend the current measurement we use shunt resistance across the meter, and to extend the voltage measurement in PMMC instrument we use high resistance in series with the meter. So without using the extension, this instrument measures up to 50 milliampere and voltage up to 100 millivolt. So here question is, how much amount of voltmeter use voltage without using series resistance, that means extension. So here up to maximum voltage used by this instrument is up to 100 millivolt. So this is what C is correct option for this question. Next, a voltmeter used for measurement of line voltage 230 volt indicates 232 volt. Find the static error. Here question is, voltmeter used for the measurement of voltage of 230 volt. That means true value of voltage is what? 230, but this instrument measured this value of voltage 232. That means measured value is what? 232. 232. Here question is, what is static error? Static error, we know error is what? Error is equal to measured value minus true value. Here measured value is Vm and the true value is what? Vt. So measured value 230 minus measured value 232 minus 230. If you simplify, you get 2. So by this instrument, error is what? Error is equal to 2 volt. So the correct answer for this question is option D. Next, in a potentiometer circuit, a cell of 1.5 volt EMF gives balance point at 30 centimeter length. Here question is, a potentiometer circuit having 1.5 volt is balanced at 30 centimeter. 30 centimeter length of wire. If another cell of 2.5 volt EMF replaces the first cell, then what is the length of wire with the balance point occur? Here question is, what is the length of wire for which 2.45 volt is balanced? You know, in potentiometer there is a slider where we connect the cell which is need to measure their value, and we adjust the slider until the potentiometer until the galvanometer, that means PMMC instrument connected in this setup is reflect zero value, and this happens when the voltage to be measured and the reference voltage is same. So here question is, this instrument balanced when 1.5 volt when the instrument has 30 centimeter wire length. What is the value of this? You know, in potentiometer, value of voltage to be measured is directly proportional to length of the wire. Voltage to be measured is directly proportional to length of the wire. If you take this as a V1 and this as a V2, this is L1 and this is L2, then here we write V2 by V1 is equal to L2 by L1. So here we say, write V2 is what? Equal to V1 into, that means V1 is 1.5, L2 don't know, here need to find the value of L2. So here directly we write in here, we write as L2 is what? L2 is equal to V2 by V1. V2 is 2.5 upon V1 1.5 into V1. Here V1 is what? Here we write V2 by V1 into L1. L1 is 30. If you simplify this, you get their value, and this is equal to what? 5, 3. This is, that means their value comes to 50 centimeter. So this potentiometer provides balance at 50 centimeter for the voltage of 2.5 volt. You can simply remember that potentiometer balance provide when the voltage is directly proportional to length. So the correct answer for this question is option A. Option A. Next, question is, a slide wire is used for measurement of current in a circuit. Slide wire means, that means potentiometer, where we use slide wire to balance the circuit. Here question is, a slide wire is used for the measurement of current in a circuit. The voltage across a standard resistance of 1 ohm standard resistance of 1 ohm is balanced at 75 centimeter. That means when the standard resistance is 1 ohm, this instrument provides balance at 75 centimeter length. Find the magnitude of current if the standard cell having an EMF of 2 volt. Now question is, find the magnitude of current. What is the value of current? Find the magnitude of current if the standard cell having an EMF of 2 volt is balanced. Here, when the EMF of a standard cell is equal to 2 volt and this provides balanced at 50 centimeter. Again, question is, a slide wire is used for the measurement of current in a circuit. The voltage across a standard resistance of 1 ohm is balanced at 75 centimeter. Find the magnitude of the current if the standard cell having an EMF of 2 volt is balanced at 50 centimeter. Here question is, when the slide wire measures the voltage 2 volt, then this provides balance at 50 centimeter. Next question is, what is the value of current when the standard resistance is 1 ohm and this provides balance at 75 centimeter? We know in slide wire, voltage measured is directly proportional to length. Voltage measure is directly proportional to length. So first of all, here we find, take this as standard 2 and take this as standard 1. This is L1, here this is L2. L2. We now need to find the current I1 when the instrument is provide balance at 75 centimeter and the standard resistance is what? 1 ohm. To find out this, here we first use V1. Here we find voltage across this VSTD 1. So VST 1 upon VSTD standard 1 upon V standard 2 equal to L1 by L2. L1 by L2. So here V standard 1 is what? L1 by L2. L1 is 75 and L2 is 50 into VSTD 2. This is 2. Simplify this. Here this comes a 3. A standard voltage is what? 3 volt. Now need to find the current. Here this voltage comes across the resistance of 1 ohm. So we know V is equal to what? V is equal to IR. That means I is what? Current ISTD 1 is what? VSTD 1 upon R STD 1. Here VSTD is 3 and the resistance is what? Resistance is 1. So current flowing in the circuit when the voltage across the 1 ohm resistance, standard resistance is 3 volt and their value is what? 3 ampere. 3 ampere. So the correct answer for this question is option D. Option D. Option D. Now move to the next question. Next question is, which of the following is not an application of DC potentiometer? DC potentiometer is used mainly for the measurement of voltage, but you can measure other things as a resistance. You can measure by using this resistance, current, power. But this instrument cannot be used for the measurement of self-inductance because self-inductance is a AC nature. So here we not use DC potentiometer for the measurement of self-inductance. So the correct answer for this question is, which of the following is not application of DC potentiometer? DC potentiometer capable to measure resistance, current, power, but not measure inductance. So the correct answer for this question is option D. Next, the portable instrument which is generally used for testing of installation insulation resistance is an insulation resistance tester. Here the question is insulation resistance. Insulation resistance, you know, insulation resistance is the higher value of resistance, or to measure higher value of resistance, instrument used is what? Meager method, meager instrument. Here wattmeter is used for the measurement of power. Galvanometer, either the galvanometer is a voltmeter or current. Galvanometer, we use galvanometer means what? PMMC instrument, and PMMC instrument used for the measurement of voltage or current. This is voltmeter, this measures voltage, and here need to measure the insulation resistance, and for this we use meager method. Next, in potential transformer, the secondary winding is designed so that a voltage of dash is delivered to the instrument load. Potential transformer is used to reduce high voltage to low value of voltage in that range which is capable to measured by the instrument which is connected on the secondary side, and the range of the secondary side voltage of potentiometer is lie from 100 to 120 volt. Here potentiometer convert high voltage to the low voltage, high voltage to low voltage in the range of this to measure the voltage. So here correct answer for this question is option A. Next, the dynamometer type wattmeter consists of dash fixed current coils connected in series with load. In dynamometer type instrument, fixed coil current is divided in two parts. Fixed coil current is divided in two parts. This is fixed coil, and this is also fixed coil. This is divided in two parts to get uniform magnetic field of the moving coil instrument. This is fixed coil and this is moving coil. So the dynamometer type wattmeter consists of two fixed current coil connected in series with the load. This is connected in series with the load. So the correct answer for this question is option A. Next, which of the following method is the method of measurement of high resistance? High resistance is measured by which method? Here first is direct deflection method. Yes, direct deflection method is used for the measurement of high resistance. Second, meager bridge method. In previous question we discussed meager is the meager is the instrument which is used for the measurement of high value of resistance. So here both are correct. That means option D. Both direct deflection method and mega ohm bridge method here this is not a meter, this is by mistakes I see. This is meg ohm breeze and meg ohm breeze method is also used for the measurement of high resistance. So both are correct. Next, which of the following is correct regarding potential transformer? First, potential transformer are used to operate voltmeters. The potential coils of a wattmeter, and relays form high voltage lines. Question is, potential transformer are used to operate voltmeter. The potential coils of wattmeter and relays from high voltage lines. Yes, those which is need to measure value connected on high voltage side of the instrument, or you may say supply side of the potentiometer. Here question is, potential transformer are used to operate voltmeter. Potential coils of wattmeter and relays form high voltage lines. All these values which is need to measure or protect is connected on high voltage side, and the instrument which measure that value of voltage is connected on low voltage side. Second, the design of potential transformer is quite similar to power transformer. Yes, but the loading of potential transformer is always small. Yes, either you see a potential transformer or power transformer, there is only one difference. Potential transformer secondary, that means load side voltage is measuring capability is very small, sometimes few volt ampere. So both are correct, both options are correct. Next, which of the following statement is correct regarding de Sauty breeze? First, the breeze is the simplest method of comparing two capacitance. De Sauty breeze is used for the measurement of capacitance. Second, the advantage of de Sauty breeze is its simplicity, but disadvantage is nullified by the fact that it is impossible to obtain balance if both the capacitors are not free from dielectric loss. Yes, de Sauty breeze is used for the measurement of those value of capacitance which is free from dielectric loss. If the capacitance has dielectric loss, then this instrument is not capable to measure the value of capacitance. So, de Sauty breeze is used for the measurement of capacitance which is lossless. So both statement of this question is correct. That means option C is. Next, which of the following statement is correct regarding induction type wattmeter? Induction type wattmeter, you know, energy meter is an induction type instrument, and this measures power, and when you multiply the time measurement of power by how much amount of time, then you know energy is what? Energy is product of power into time. So basically, energy meter measures power, and how much times of power measured, you can simply multiply time in the power, you get the value of the reading. Here, first statement is induction type wattmeter consists of two electromagnets. Yes, in induction type instrument, that means in energy meter, two coil, one is series coil, that means current coil, and other is potential coil or shunt magnet. Here, in electrodynamometer type instrument, two coil, one is current coil and other is pressure coil. Current coil is current coil provides a series magnet, or and pressure coil used as a shunt magnet in the instrument. Next, a thin aluminum disc is mounted between two magnets. Yes, in between the series and shunt magnet. Series magnet means current coil and pressure shunt magnet means pressure coil. In between these coils, rotating disc is connected. Rotating disc is connected. So both statements are correct of this question. So the correct option is option A. Next, in the context of meter, the voltage range of the instrument can be controlled by a voltage selector switch. Here, question is, in the context of meter instrument, voltage is controlled by voltage range of the instrument is controlled by voltage selector switch. This can be dash with the current coil. Voltage selector switch is a variable resistance which is connected in series with the current coil. Voltage selector switch is what? In the context of a meter, voltage range controlled by a voltage selector switch, this can be a variable resistance connected in series. This is what? Voltage selector switch is a variable resistance connected in series with the current coil. So the correct answer for this question is option B. Next, current transformers are always used with the dash closed through ammeters, wattmeter, current coils or a relay. Current transformer, you know, either the power transformer or potential transformer or current transformer. Transformer has two winding, one is a primary and other is secondary. In primary side, we connect the high voltage or high value of current, and where to measure the this value of current is connected on secondary side. So here we current transformer cannot used without connecting or closing the secondary of this instrument. So secondary winding of this circuit must be closed, otherwise high voltage develop on the secondary side which may harm those who are appearing across around the instrument, because this high voltage may dangerous for those who performing the test. So secondary must be closed for current transformer. Next, which of the following is the method of measurement of low resistance? Low resistance can be measured by Kelvin's double bridge. Yes, Kelvin double bridge is used for the measurement of low resistance. Next, potentiometer method. Yes, potentiometer method is capable to measure low value of resistance. So both statements are correct. That means option A is correct. Next, the principle of dash is particularly adapted to application in portable instruments measuring insulation resistance. Portable instruments which measures insulation resistance, which principle is used? Principle used for the portable instrument which measuring the insulation resistance is ratio meter ohm meter. You remember this ratio meter ohm meter principle used in portable instrument which measure insulation resistance. So the correct answer for this question is option B. Next, what is the disadvantage of electrodynamometer instrument? One, less expensive than PMMC. No. Low torque to weight ratio. Yes, this is the disadvantage of electrodynamometer type instrument, because their torque to weight ratio is less. So the correct answer for this is option B. Next option is low friction losses. high sensitivity, no. If the torque to weight ratio is low, then in this case the instrument produce error in the measurement. So here sensitivity is not high of this instrument. Here disadvantage is what? This instrument has low torque to weight ratio. Next, which type of bridge used to measure self-inductance in terms of mutual inductance? Carey-Foster bridge is used for the measurement of resistance. Hayes bridge used for the measurement of inductance. Here question is, which type of bridge measures self-inductance in terms of mutual inductance? Hayes bridge does not measure self-inductance in terms of mutual inductance. So the next is Campbell modifications of Heaviside bridge. Yes, Heaviside bridge, Campbell modification of Heaviside bridge measure self-inductance in terms of mutual inductance. So the correct answer for this question is option C. You know, Maxwell inductance capacitance bridge measure self-inductance by comparing with capacitor. Next, which error is indicated zero error in instrument? Here, random error, this is unpredictable. You cannot predict what is the error comes, because this is random error. Next is gross error. This error is happened due to the human mistakes in a reading measurement. And next, indefinite error, we don't know what is the value indefinite. That means random, you may compare it with random error. Here zero error in the instrument is indicated. Zero error of the instrument is indicated in systematic error. Systematic error, because this error is predictable. If you not provide the supply in the instrument, then in this case the reading source by the instrument is 0. So this is predictable and this comes in systematic error. So the correct answer for this question is option A. Next, what are the errors when measuring power by single phase energy meter? Single phase energy meter in two circuits. Pressure coil lags the voltage by 88 degree. Here question is, what are the error when measuring power by single phase induction energy meter? We know percentage error in single phase induction type energy meter is sine delta minus phi minus cos phi upon cos phi into 100. Here delta is the angle of voltage and pressure coil flux, or you may say pressure coil. Here the pressure coil lags the voltage by 88 degree. That means delta is what? 88 degree. And power factor of unity and 0.5 lagging. First, need to find percentage error when the power factor is unity. Power factor unity, that means cos phi is equal to 1, that means phi equal to 0 degree. In this case, when you find percentage error, put this value. Sine 88 degree minus 0. Sine 88 minus cos phi. Cos phi is what? 0. Cos 0 is what? 1 upon 1 into 100. When you simplify this, you get their value, and this comes to, I think you simplify this. When you simplify, you get their value. and this comes to minus 0.061. When you simplify, their value comes to minus 0.061. Minus 0.061. Similarly, you can find when the power factor is 0.5 lagging. Power factor 0.5 lagging. 0.5 lagging. That means cos phi equal to 0.5. 0.5 means 1 by 2. We know when phi is equal to 60 degree, value of cos phi is equal to what? 1 by 2. Put this value here, then you get percentage error. Percentage error is what? Sine delta minus phi. Delta is what? 88 degree, because this is the angle of voltage and pressure coil flux. So 88 minus phi is 60 degree upon sine delta minus phi minus cos phi upon cos phi into 100. When you simplify this, you get their value, and this comes to minus 6.1. Minus 6.1. When you simplify, you get their value. So the correct answer for this question is minus 0.061 and minus 0.061 and minus 6.1. So the correct answer is what? Option D. Option D. You remember only percentage error in the induction type energy meter is what? Sin delta minus phi minus cos phi upon cos phi, where delta is the angle of pressure coil and voltage supplied in the instrument. Phi is what? Phi is the power factor angle. Next, the ramp type digital voltmeter uses dash time measurement based linear ramp strategy. Yes, ramp type digital voltmeter use time measurement based linear ramp strategy. A strategy used in ramp type digital voltmeter is time based. Time based. So the correct answer for this is option A. Next, a set of independent current measurements taken by 4 observers was recorded as this. The value of arithmetic mean. Arithmetic mean is what? You know, arithmetic mean is what? Arithmetic mean is equal to sum of the observation upon number of observation. Arithmetic mean is what? You know, sum of observation upon number of observation. Number of observation. Here the total observation is 104 107.02 plus 107.11 plus 107.08 plus 107.03. Here number of observation is what? Total number of observation is 4. When you simplify this, you get the arithmetic mean of this observation, and this comes to 107.06. When you simplify, you get their value 107.06 milliampere. Milliampere. So the correct answer for this is option B. Next, the voltage coil in a wattmeter has wattmeter, that means electrodynamometer wattmeter. In electrodynamometer wattmeter, 2 coil, one is the current coil and other is the pressure coil. You know, pressure coil has a, if the pressure coil is purely resistive in nature, then in this case measurement of the wattmeter is watt meter gives true value of measurement, but practically pressure coil is inductive in nature. That's why some error occurs in the measurement. So here voltage coil in a watt meter has inductance and resistance. Inductance and resistance. So the correct answer for this question is option B. Next, the SI unit of meter constant in a single phase energy meter. You know, meter constant is what? Number of revolution upon energy consumed. Energy consumed. And the unit is what? Unit of this is revolution per kilowatt hour. Revolution per kilowatt hour. So the correct answer for this question is option B. The ratio of error to the specified magnitude of quantity is defined as. Here question is ratio of error to a specified magnitude of a quantity. Is defined as. Here limiting error and guaranteed error, both error are described by the manufacturer. This is the error which is predefined by the manufacturer, that if this instrument measures any reading, then their range of error comes in particular value. So this is not a ratio, this is the value of the range of the error. Next is inherent error. This error is already in measured value. Because this error is already present in the measurement. Next, you know, relative error is what? Relative error is the ratio of limiting error. Relative error is what? Relative error is the ratio of limiting error or absolute error upon true value of measurement. So this is absolute error or limiting error upon true value. This is the ratio of error to the specified value. So the correct answer for this question is option B. Next, in the single phase induction type energy meter, creeping is because of. Creeping is what? When we provide or connect the supply to the induction type energy meter, but there is no current flowing in current coil, that means load current is zero. In this case, slowly but continuous rotation of the disc obtained, and this problem is defined as a creeping, or this phenomena is a creeping. So this is happen when high voltage is connected to the supply but there is no load. So over voltage across the voltage coil. Yes, when you connect over voltage across the voltage coil, then in this case such phenomena is seen. Or you may say if you provide the high voltage in voltage coil, then this phenomena occurs. And if also overcompensate, if you compensate over for friction, then in this case also creeping is obtained. Creeping, or if you compensate friction, make the disc friction free, in this case also this problem is arises. So the correct answer for this is when you connect a high voltage in the pressure coil and there is no current flowing through the current coil or no current of the load, then in this case such problem is arises. Next, which of the following option defines dead time? No, dead time is what? When you provide a supply to the instrument, some output is seen by the instrument. I don't care how much, what is the value of output. Here we provide a input 1 and we get input 1, we get some output. Now, when you when you change the input and let's input is changes and it becomes true at time, anytime you may here take in t1 time you change the input. Then here we see how much time after these changes reflect by the instrument, and the time taken by the instrument to reflect that change is called a dead time of the instrument. If the instrument, when you change the input and at that instant output it changes, then you can say there is no any dead time of this instrument. But if you change the input and after some times these changes reflect in the output, that time is called dead time. So here the time when there is a largest change in input quantity, there is no any largest or smallest change. Only if we create the change in the input, how much time after the instrument reflect that changes. The time before which an instrument starts to respond after the output has been changed. Yes, this is correct. The time before which an instrument starts to respond after the output has been changed. Output has been changed. When you change the output, how much time after this reflect? Next, what is the range of instrument if 5% limiting error? Limiting error is 5%. Is produced when the measured value is 5 ampere with 1% guaranteed accuracy error. Guaranteed accuracy error is equal to 1% of full scale by an instrument. Question is, what is the range of instrument? Need to find a range of instrument. A range of instrument is what? A range of instrument is what if the limiting error is 5% and measured value is 5 ampere. 5 ampere. Need to find, and here guaranteed accuracy of this instrument is 1%. Question is, what is the range of the instrument? We know limiting error is equal to error in measurement upon measured value into 100. Here limiting error is what? Limiting error 5. You can find error in measurement. Error in measurement is what? Limiting error, that means 5. Measured value is what? Measured value 5 upon 100. That means here if you simplify this, you get 0.25. Now need range. Here we know how much error occurs in the measurement, and this is what? 0.25. Need a range, that means full scale value of the measurement. Full scale value of the measurement. If you write this here full scale, then you see percentage guaranteed accuracy percentage guaranteed accuracy error is equal to error in measurement upon full scale value value into 100. Here we know guaranteed accuracy is what? If you take full scale value, then you simply full scale value is what? Full scale value error in the measurement is what? 0.25. Here we find by using solution Percentage error is 1. Percentage error is what? 1. 1 into 100. So their full scale reading is what? 25. 25 25 ampere. 25 ampere. 25 ampere. So here what I see, minimum value of the measurement by this instrument is 0 ampere, and the maximum or full scale value of this instrument is what? 25 ampere. That means range of this instrument is what? 0 to 25 ampere. You remember this formula. Here first we use limiting error is what? Error in the measurement divided by measured value. By this, here we find error in measurement. How much amount of error occur in the measurement, and their value is 0.25. Now, this question also mentions guaranteed accuracy in the measurement is what? Given 1, and we know guaranteed accuracy is what? Error in measurement upon full scale. That means when you measure full scale value, then this instrument is defined the maximum error in the measurement is guaranteed accuracy. By this we solve, and here we get full scale range 25 ampere. So the range of this instrument is what? From 0 to 25 ampere. Next, the deflection of indicating pointer of an electrodynamometer instrument is proportional to dash RMS current flowing through the fixed coil. Next, the square of current flowing through the moving coil and fixed coil. We know in electrodynamometer type instrument, the deflection of the indicating pointer of instrument is proportional to, deflecting torque developed in electrodynamometer type instrument is what? I1 I2 dm by d theta, where I1 is the current flowing in fixed coil, and I2 is the current flowing in moving coil. If here question is the square of current flowing through moving coil, no. The mean of the current, no. Here question is the current flowing and controlling torque is what? Tc equal to k theta. If you simplify this at balance, Tc equal to Td, then k theta is what? I1 I2 into dm by d theta. If you simplify this, you get deflection of the pointer is directly proportional to product of current flowing in the fixed coil and moving coil. Fixed coil and moving coil. So if fixed coil and moving coil both are connected in series, then in this case deflection is directly proportional to a square of current. That means deflection obtained in electrodynamometer not only by the potential coil or current coil. This deflection occurs for the current of both coil. So here the correct answer for this question is option B. Next, which of the following is not a characteristics of PMMC instrument? Non-uniform scale, yes. PMMC instrument has uniform scale, so this is not a characteristics of PMMC. Used for DC measurement, yes, this is characteristic. No hysteresis loss, yes. High accuracy, yes. So the correct answer for this question is option A. Their scale is not a non-uniform. Electrostatic type instruments are primarily used as electrostatic type instruments primarily used for measurement of voltage in kV range. That means high value of voltage is measured by the electrostatic instrument. So option B is correct. Next, which of the following characteristics is not desirable in measuring instrument? Linearity, this is also desirable. repeatability, if the measurement is repeated, that means if you provide the same amount of input and the measurement shows same reading, then that means the measurement has a highly precise value. Next, accuracy is also drift. There is no need of a drift in the measuring instrument. So here question which is not desirable characteristic. So here drift is not a desirable characteristics of the measurement or measuring instrument. Next, calculate the resolution of 3-digit 0 to 1 volt digital voltmeter. Resolution of digital voltmeter is equal to range of meter or range of voltmeter upon 10 to the power n. Here the range of this voltmeter is what? 0 to 1, that means maximum is what? 1 volt, and this is what? 3 digit. So if you take this 10 to power 3, then this comes to 0.001. 0.001. So resolution of this instrument is what? 0.001. That means option A is correct. Next, a 0 to 200 voltmeter, a range is given. Range is 0 to 200. Voltmeter has guaranteed accuracy of 0.5% of full scale deflection. The voltage measured by this instrument, measured voltage is 50 volt. Find limiting error. Such types of question we discussed previously. Here question is, what is the value of limiting error? Limiting error. We know limiting error is what? Limiting error is equal to percentage limiting error is equal to error in measurement upon measured value into 100. To find out limiting error, need measured value. Here measured value is given. Need what is the value of error in the measurement. Here guaranteed accuracy is given. You know, percentage guaranteed accuracy is equal to what? Error in measurement upon full scale value. Full scale value into 100 need for error in measurement. Here this is what? Percentage guaranteed accuracy, this is 0.5, and the full scale range of this instrument, minimum measurement is 0 and maximum is what? 200. So full scale is what? 200. So here we write guaranteed accuracy 0.5 and full scale is 100 upon 100. So error in the measurement is what? 0.5. Now here need to find limiting error. Take this. Error in measurement is what? 0.5, and measured value is what? Measured value is 50 volt. 50 volt into 100. If you simplify this comes to 1. So the limiting error of this instrument is what? When this instrument measured 50 volt, then in this case limiting error of the instrument comes to 1%. That means option C is correct. Next, in wire wound standard register, the bifilar winding is adopted to reduce dash. Option A, aging effect. Second, self-inductive effect. third, stray capacitance, fourth, skin effect. Bifilar winding is adopted to reduce self-inductive effect of resistance. Bifilar winding is used to reduce self-inductive effect of the wire. Self-inductive effect of the wire. Next, in induction type energy meter, dash error is caused due to overcompensation for friction. This part is also discussed in previous question, where we see creeping phenomena occurs for two cases. One, either the instrument is connected to over voltage or higher value of voltage, or second is if you overcompensated for friction free of the rotating disc. In this case also creeping phenomena occurs. Next, which of the following condition must be satisfied to measure the power delivered to a three-phase load using 2-watt meter? 2-watt meter is used for three-wire connection. Either the load is balanced or unbalanced. Load must be unbalanced. No, this instrument is capable to measure both unbalanced or balanced load. Load must be connected to the source through 4-wire. No, this instrument only measures 3-wire instrument. Load must be connected to source through 3-wire. Yes, load must be balanced. Here this instrument measure both balanced or unbalanced load, but 2-watt meter measure. Here question is, which of the following condition must be satisfied to measure power delivered? 2-watt meter method is used for the measurement of three-phase 3-wire system. So option C is correct. Next, in the cathode ray tube, distance of dash is minimum from the phosphor screen. If you see the cathode ray oscilloscope, then the far distance from the phosphor screen is cathode. Then the reduced distance is a grid. Then we use cathode, then grid, then as a vertical plate, Y plate, and then horizontal plate, and then a screen. So in cathode ray tube, distance of dash is minimum from phosphor screen. Minimum distance from the phosphor screen is horizontal plate. Then distance increase. That means here you see distance increases. Near the screen is horizontal plate, then vertical plate, then grid, then cathode, which emits the electron. So B is option correct. Next, a conventional oscilloscope has bandwidth of 100 megahertz. The rise of the CRO is approximately, we know, rise time of the CRO or any electronic device is equal to 0.35 upon bandwidth. Bandwidth second. Unit is what? Second. So here 0.35. And bandwidth is what? Bandwidth is given 100 megahertz. That means 100 into 10 to power 6 second. When you simplify, you get their value, and this comes to 3.5 nanosecond. When you simplify, their value comes to 3.5 nanosecond. 3.5 nanosecond. So option D is correct. Next, Maxwell breeze is used for the measurement of for the measurement of dash having Q factors. Maxwell breeze is used for the measurement of inductance which quality factor is medium. That means they lies between 1 to 10. 1 to 10. So here Maxwell breeze is used for the measurement of inductance. Measurement of inductance. So option C is correct for this question. First question is, which of the following is not a valid advantage of cell type transformer over core type transformer? We know transformer has two types of construction. One is cell type and other is core type. If we comparing cell type and core type transformer, then you find that in cell type transformer, iron part is more and winding is less. But in core type transformer, iron part is less and winding is more. If you compare cell and core type, you find that in cell type there is a 3 vertical limb, 1, 2 and 3, but in core type there is only 2 vertical limb. In cell type transformer, winding placed on the central limb, but in core type transformer, winding placed on both vertical limb, this and this. Here question is, which of the following is not a valid advantage of cell type transformer over core type transformer? First, losses are less. Yes, in cell type transformer, losses are less as compared to core type, because here iron loss is slightly more, but copper loss is less. Due to this, overall losses is less as compared to core type transformer. In core type transformer, iron loss plus copper loss, and copper loss is more in this because winding in conductor winding or winding is more number as compared to cell type. So the overall losses in core type is more as compared to cell type. So here this is the valid advantage. Second, maintenance is easy. No. Cell type transformer has more maintenance complicated as compared to core type transformer because their construction is so complex as compared to core type transformer. So this is not a valid advantage. So the correct option for this question is tell me which option is not a valid advantage of cell type transformer. Cell type transformer has complex construction. Due to this, their maintenance is not easy. So the correct option is option B. Next. For a synchronous generator supplying a balanced three-phase load. For a synchronous generator supplying a balanced three-phase load, the armature reaction flux is dash in magnitude and rotates at dash speed. As in this question mentioned that the load is balanced. If the load is balanced, then current supply to the load is also balanced. Current is balanced. And we know armature current is responsible for the production of armature flux. Armature flux. If armature current is balanced, that means fixed, then flux is fixed. Armature flux is fixed. Phi A is constant. So here question is, the armature reaction flux is variable or constant? Armature reaction flux is constant. Next part is, a speed at which the armature flux rotate is the synchronous speed. Synchronous speed because the rotor rotates at synchronous speed in induction motor, or you simply say SP induction motor, sorry, by mistakes I say here synchronous generator is rotating at synchronous speed. Here you must correct it. Here synchronous machine always rotates at synchronous speed. So the correct answer for this question is, flux developed is constant and the speed of rotation is what? Synchronous speed. So correct option is option D for this question. Next, with reference to wave winding used for DC generator, wave winding used for DC generator, state whether the following statements are true or false. First statement is, wave winding is used for high current. No, wave winding used for low current and high voltage. So first statement is wrong. Next, the efficiency of wave winding is higher as compared to lap winding. Yes, efficiency of wave winding is higher as compared to lap winding because in wave winding number of parallel path is low as compared to lap winding. So statement 1 is false and statement 2 is true. That means option B is a correct. Next, for a DC motor, gross mechanical power developed by the motor is maximum and the motor supplied through a 220 volt. 220 volt. What will be the back EMF? We know when the DC motor produce a maximum power, this happens only when the back EMF is equal to half of the supply voltage. DC motor develops maximum power. This happens when back EMF is equal to half of the supply voltage. Here question is, what is the back EMF? Supply voltage is mentioned, so we find 220 divided 2 is equal to 110. That means this motor induced EMF is 110 volt at that time when the machine develops a maximum power. So the correct option is option D. Next, a single phase transformer has 200 primary and 700 secondary terms. N1 is 200 and N2 is 700. If the primary voltage is 100 volt, the secondary voltage is what? We know in transformer V2 by V1 is equal to N2 by N1. Need to find V2. V2 equal to what? V1, that means 100 into N2 by N1, that means 700 divide 200. If you simplify this, you get their value and this comes 350. So here we get the secondary voltage of this transformer is 350 volt. Next, a properly shunted center zero galvanometer is connected in the rotor circuit of a 6-pole 50 Hz wound rotor induction motor. If the galvanometer makes 90 complete oscillation in 1 minute. Here question is, a properly shunted center zero galvanometer is connected to the rotor circuit. Galvanometer is connected to the rotor circuit and circuit of a 6-pole 50 Hz induction motor. Induction motor having the number of pole is 6 and the frequency of supply is 50 Hz. If the galvanometer makes 90 complete oscillations in 1 minute. Here galvanometer is connected with rotor circuit and the oscillation produced by the galvanometer is 90 complete oscillation per minute. That means a speed of the frequency of the rotor is equal to the frequency of the galvanometer oscillation. So here we mark the rotor frequency is what? 90 oscillations per minute. We change this in terms of second because we know frequency is in Hertz and frequency is in Hertz. So here we write this in terms of second. 90 into 90 oscillations per minute, that means 60 seconds. If I simplify this 90 upon 60, here we get 9 upon 6 Hertz. 6 Hertz. Calculate rotor speed. Question is, what is the rotor speed of this induction motor? We know rotor speed is what? NR. NR is equal to NS into 1 minus S. To find out rotor speed, need slip and synchronous speed or rotating magnetic field speed of this induction motor. First, we find slip. We know Fr is equal to S times of supply frequency. So here supply frequency is known and Fr is also known. Fr is what? 9 upon 6 S and F is 50. F is 50. If you simplify this, you get slip is equal to 9 upon 5 into 50 into 6, that means 9 upon 300. Now synchronous speed is what? Ns equal to 120 F by P. F is the supply frequency. Here supply frequency is 50 and the number of pole is what? 6. If you simplify this, you get 1000 RPM. 1000 RPM. Put this value in this equation, you get rotor speed Nr is equal to Ns, that means 1000 into 1 minus S, that means 9 upon 300. When you simplify, you get the rotor speed and this comes to when you simplify this comes to 970 RPM. 970 RPM. So the correct answer for this question is option C. Next, a 220 volt DC shunt motor runs at 630 rpm. A 220 volt shunt motor runs at 630 rpm. 630 rpm. 630 rpm. When the armature current is 50 ampere. Find the speed if the torque is doubled. Question is, find the speed if the torque is doubled. Let, when the machine operates at a speed 630 and armature current 50, torque developed, take this as a case 1. N1, IA1 and torque, let torque develop is T1. Torque develop in this case is T1 and it is equal to what? T. Question is, find the speed if the torque is doubled. What is the value of speed when the torque is doubled? That means T2 is equal to what? 2 times of T1 and the value of T1 is what? T. Assume armature resistance is 0.2. Here armature resistance is 0.2. 0.2. Here question is, a motor having supply 220 and the speed 630, in this case current drawn from the source or armature current is 50 ampere and torque is T. Need to find a speed. We know to find out the speed, if we draw the electric circuit of the shunt motor, this is electric circuit of shunt motor. Electric circuit of a shunt motor. We know to find out the speed, here we take two case, one N1 when the speed is 630 and need to find when the speed is what? When the torque is twice the initial value. To find out the speed, we know N directly proportional to EB upon phi. As this is shunt motor, we know in shunt motor flux is constant, and if the flux is constant, N directly proportional to EB. Now take two cases, N2 upon N1 is equal to EB2 upon EB1. Here need to find N2, N1 is given, need EB1 and EB2. If you apply KVL in this loop, then you find here, then you find EB is what? Here this is EB back EMF. Apply KVL in this loop, we write V minus IA RA minus EB equal to 0. So EB is what? EB is equal to V minus IA RA. Here to find out the EB, need VIA RA. In this question V RA is mentioned, and in first case current drop, armature current is also mentioned and it is 50 ampere. Need current drawn from the source when the torque is twice the initial value. To find out this, we know, take this as equation 1. We know torque is what? Torque directly proportional to phi into Ia. As the machine is shunt, flux is constant. Flux is constant, so torque directly proportional to Ia. Take two cases, T2 upon T1 is equal to Ia2 upon Ia1. As T2 is what? 2 times of initial torque, 2T, 2T, and the T1 is what? T equal to Ia2 upon Ia1. Ia1 is equal to what? Ia1 is equal to 50. If you simplify this, you get armature current is 100 ampere. Now here we find it, the armature current when torque becomes twice the initial value, then we can easily find the back EMF at N1 speed and at N2 speed. So at N1 speed, at N1 speed, EB1 is what? EB1 is equal to V minus Ia1. When the speed is N1, armature current is what? 50 ampere. So here we write EB1 is equal to, here we don't not change our supply voltage. Here only we change what? Torque. So EB1 is equal to V minus Ia1 RA is the armature resistance. V is what? V is equal to 220 minus Ia1 is equal to 50, and RA is the armature resistance. Their value is equal to 0.2. When you simplify this, you get this is 10. When you subtracting 10 from 220, you get 210. Similarly, at N2 speed, here we write EB2 is equal to V minus Ia2 RA. V is equal to 220 minus Ia2 is 100 and RA is what? 0.2. Here if you multiply this comes to 20 and subtract 20 from this equals to 200. Now put this in equation 1. So from equation 1, here we write N2 is equal to N1 into EB2 by EB1. N2 is what? N2 is equal to N1. N1 is 630. 630 into EB2 upon EB1. Here EB2 is 200 and EB1 is 210. When you simplify this, you get the speed N2. And here if you simplify this, their value comes to 600 RPM. 600 RPM. So the correct answer for this question is option C. Option C. Next. In DC motor, difference between armature torque and shaft torque is called dash and is due to, in DC motor, if you recall the power stages of the DC motor, then first we provide electrical input. When you provide electrical input, copper losses happen. After the copper losses, we get developed mechanical power. After this, iron and friction losses happen. Then finally we get output power. Here question is, In DC motor, difference between armature torque developed due to the mechanical power developed by the machine, and shaft torque is obtained due to the output power. So, the difference between armature torque minus shaft torque gives lost torque, and this loss is happened due to this iron and friction losses. Lost torque due to iron and friction. Lost torque due to iron and friction. So here difference between armature torque and shaft torque is lost torque, and this torque is happened due to iron and friction. So correct option is option D. Next, in the field flux control method of DC motor, field flux control method of a DC motor, a speed control, dash power and torque is obtained for a speed above base speed. Here question is, to get the speed above the base speed, we apply flux control method. Flux control method. Here we know N directly proportional to EB upon phi. Here speed is what? Above the base speed, and speed is inversely proportional to flux. To get a speed above the base speed, this obtains when the flux is reduced. Flux is reduced. Now question is, what is the value of power and torque in this case? In this case, we know torque is what? Torque is directly proportional to phi into Ia, as this is a in field flux control method of a DC motor speed control. DC motor speed control, power and torque is obtained for a speed above base speed. In DC motor, armature current is limited. Armature current is not much higher value. Armature current is what? Armature current is limited. As to get the speed above the base speed, here we decrease the flux. So if you decrease the flux, then this value does not change more. So here armature current change is limited, or you may say armature current is fixed. As flux decreases, so here we say torque decreases. So if we apply the field flux control method of a speed control in DC motor to get the speed above base speed, then in this case torque reduce. Now power is what? We know power is what? Product of torque into a speed of the motor. A speed of the motor, as here we get a speed above the base speed. A speed is what? Higher, and torque is what? In this case torque is reduced. Torque is reduced. Here what I see? Torque is reduced and speed is increasing. Due to this, power does not change, their value becomes a constant in this method of speed control. So here question is, in the field flux control method of a DC motor, a speed control, dash power, that means constant power, and torque, constant power and torque is obtained for speeds above base speed. Here torque is what? Here torque is variable by mistake, and torque, and here something fill in the blanks. Here variable torque is obtained for a speed above base speed. A speed above base speed. So the constant so the correct answer for this question is option D. In field flux control method, power is constant and torque is variable. Next, a synchronous generator is rated at 40 MVA, 10 kV, 50 Hz. The base impedance of the generator will be, we know how to find the base impedance. Z base is what? kV base square upon MVA base. Here, voltage is what? 10 square upon MVA 40. If we simplify 100 upon 40, in this case it comes to 2.5 ohm. So for this machine, base impedance is equal to what? 2.5 ohm. That means correct option is option D. Next, in DC machine, the method of achieving good commutation with the help of interpoles is called. First of all, you know, commutation is what? Reversal of current in the coil is called commutation. If the reversal of current in the coil happen in commutation period time, then we say commutation is good commutation. Here, to get in DC machine, to get good commutation, we use interpoles. We use interpoles. You know, due to the reactance voltage, armature flux, armature flux armature flux creates problem for the current reversal in the coil. To minimize this effect, we use interpole winding, and the interpole winding generates the voltage which cancels the reactance voltage, and when the reactance voltage is cancelled or counter, then in this case we get the good commutation of the machine. So here interpoles winding is used to get good commutation as this develops a voltage. So this is called voltage commutation. This is what? Voltage commutation. Next, with reference to the skewing of a case rotor of an induction motor, identify whether the given statements are true or false. In a squirrel case induction motor, rotor bar is slightly skewed to the rotor slot is slightly skewed to avoid the magnetic locking effect, and also it reduces the noise of the machine. So here question is, identify whether the given statements are true or false. When we using a skewing of the case rotor, then due to a skewing, noise is reduced. Yes, this is a correct. This is correct statement. When you use a skewed rotor, in this case noise is reduced. Next part is the locking tendency of the rotor is reduced. Yes, when we use a skewed rotor, then in this case rotor locking tendency of rotor and stator flux is reduced. So this avoid the locking of the rotor flux and stator flux. So both statements are correct. That means option D is correct. Next, in a single phase transformer, transformation ratio of transformation is 2. and the secondary resistance is 0.24. Find the resistance of secondary in terms of primary. That means here need to find secondary resistance referred to primary side. We know secondary resistance referred to primary side is what? R2 dash is equal to A square R2. Here K is a transformation ratio. And here we use A is what? A is turns ratio. A is turns ratio, and turns ratio is reciprocal of transformation ratio. So here we write A is what? 1 by 2. Now need to find R2 dash, that means secondary resistance referred to primary. A square, that means 1 by 2 square into R2. R2 is the secondary resistance and it is equal to 0.24. If you simplify this, you get 0.06 ohm. So here what I get? When you refer the secondary resistance to the primary side, then their value is what? 0.06 ohm. So the correct answer for this question is option D. Next, in a DC machine, hysteresis losses are covered under the category of, hysteresis losses comes under the category of iron losses, because iron losses or core losses is sum of hysteresis losses plus AD current losses. So the correct option for this is option B. Next, which of the following statement about DC series motor is incorrect? First, it is a variable flux machine. This is a correct statement because series field winding is connected in series with the supply. As the load changes, current drawn from the supply it changes. So this is a variable flux machine. Next, its speed versus armature current characteristic is a straight line. No. N directly proportional to EB upon phi. EB is approximately constant whatever the value of the load. EB is approximately constant. N directly proportional to 1 by phi. Here field winding is connected in series with the motor, so current drawn from the supply or armature current is equal to, armature current is directly proportional to field flux, or field flux is directly proportional to armature current. In this case here, speed is inversely related to armature current. That means when you increase the armature current, then in this case speed decreasing. This is not related in a straight line. Its speed versus armature current characteristic is a straight line. No, this is inversely related. If you change armature current, if you increase armature current, then speed decreases. So this is not a correct statement. This is incorrect statement. Next, in case of slip ring induction motor, external resistance are connected in the rotor circuit to dash the starting torque and to dash the starting current from the supply. As we know, when we provide direct supply to the induction motor, then in this case, our current drawn from the source is 5 times of the full load current, but torque developed is 1.5 to 2.5 times of the full load torque. So, a starting torque of the induction motor is small. To increase the starting torque, we connect external resistance in series with the rotor circuit. external resistance are connected in the rotor circuit. When you connect the external resistance in the rotor circuit, in this case power factor of the rotor is increased. Power factor of the rotor is increased, and due to this a starting torque developed increases and current draw decreases. So here, in case of slip ring induction motor, external resistance are connected in the rotor circuit to increase a starting torque. And to decrease the starting current. A starting current is what? A starting current decreases because power factor improved. So the correct answer for this question is increase and decrease. That means option B. Next. Question is, with reference to given phasor diagram, current I1 is the phasor sum of. This is a phasor diagram. If you recall, this is the phasor diagram of the transformer. We know resultant current is what? Resultant current I1N1. As this is AC circuit, so here we apply phasor addition. I1N1 is equal to what? I0 N1 plus I1 dash N1. Here N1 is common in all these, so here we write I1 is equal to I0 plus I1 dash. That means when the we know when the transformer is loaded, then in this case current drawn from the supply is equal to what? No load current plus secondary current referred to primary. I1 dash is what? Secondary current. For this case here I2 is what? Secondary current. And when we change in primary side, then it becomes I1 dash. So I1 dash is equal to what? I0 plus I1 dash. For this, correct option is what? I1 is the phasor sum of I0 and I1 dash. I1 dash and I0. So option C is correct. Next, which of the following methods of a speed control cannot be used for a squirrel case induction motor? Which speed control method cannot be used in a squirrel case induction motor? First is a stator voltage and a stator frequency control. This method is used in a squirrel case. This is what? V by F method. To control the speed, we can change in direct proportion of voltage and frequency, as this is always constant. V by F is always constant. Second, a stator voltage control. To get the speed control, we change the stator voltage because we know and directly proportional to voltage upon flux. So here we applies a stator voltage control and also a stator frequency control. Here slip power recovery control is not used in a squirrel case because to apply this method we need to control the rotor winding, as a squirrel case rotor is short circuited, so you cannot create any change in the rotor circuit. So this is used in slip ring induction motor, not in a squirrel case. Slip ring induction motor, we use slip power recovery control to get a speed control of induction motor. This is used in slip ring induction motor. So here question is, which of the following method of a speed control cannot use for a squirrel case? Slip power recovery control is not used for a squirrel case. Next, A single phase transformer has 400 primary and 1000 secondary turns. Primary is 400 and secondary is 1000. If the primary is connected to 500 volt 50 hertz, primary is connected to 500 volt 50 hertz, find the secondary voltage. This is similar to the previous question. You can directly find by using the transformation ratio or turns ratio. Here need to find V2. V2 by V1 is equal to N2 by N1. By using this, V2 is equal to V1, that means 500 into N2, 1000 upon N1, 400. If you simplify this, you get their value, and this comes to 5000 upon 4, that means 1250. So in this case, secondary voltage is 1250, that means option D is correct. Option D is correct. Next. Identify whether the given statements with reference to DC machine are true or false. Swinburne test cannot be performed on DC series motor. Yes, this statement is true because Swinburne test is applied for no load test. And we know we cannot use DC series motor without load, because when you are not connecting load with series motor, then the speed of the motor is dangerously high. Due to this, Swinburne test cannot be used for DC series motor. Second statement is Swinburne test is a non-loading test. Both statements are correct. Swinburne is a no load test. So statement 1 and 2 is correct. That means option C is correct for this question. Next. Determine the regulation of a transformer in which ohmic loss is 1%. Need to find voltage regulation of a transformer in terms of percentage. Here ohmic losses, that means epsilon R is what? 1%. Here we represent ohmic losses by epsilon R. Ohmic losses by epsilon R. Ohmic losses is 1% of the output and reactance drop. Percentage epsilon X is equal to 5%. 5% of voltage when power factor is unity. Need to find voltage regulation when power factor is unity, and the resistance percentage ohmic losses 1 and percentage reactance drop 5%. We know percentage voltage regulation of the transformer is what? Percentage epsilon R cos phi plus minus percentage epsilon X, percentage epsilon X sin phi. Here power factor is what? Unity, that means phi is what? 0 degree. As power factor is unity, you cannot say the machine is operating at leading power factor or lagging power factor. Machine operates in unity power factor. So percentage epsilon R is 1, power factor is 1 plus minus percentage epsilon X 5, and sin phi, sin 0 is what? 0. So in this case, percentage voltage regulation comes to 1%. So the correct option is option A. Next, question is a 746 kilowatt 3 phase 50 hertz 16 pole induction motor has a rotor impedance of this. Full load torque is obtained at 360 rpm. Calculate the speed at which maximum torque occurs. Need to find a speed at which, that means what is the value of rotor speed at when the machine produce a maximum torque. We know rotor speed is what? Rotor speed is equal to ns into 1 minus s. To get rotor speed corresponding to maximum torque, we know slip and load is directly related. So here, to get the torque maximum, need to use slip corresponding to maximum torque. Slip corresponding to maximum torque, we know slip corresponding to maximum torque is what? R2 upon X2. Here R2 is the rotor resistance at a stainless steel and X2 is the rotor reactance at a stainless steel. This is rotor impedance at a stainless steel. That means here R2 plus J X2 is given, and this is 0.02 plus J 0.15. So here slip corresponding to maximum torque R2 upon X2, that means 0.02 upon 0.15. When you simplify this, it comes to 2 upon 15. Now put this value to find out rotor speed corresponding to maximum torque. Also need to find synchronous speed of the machine. Ns is what? 120 f. Here f is the supply frequency and this is equal to 50. 120 f by p. P is the number of pole. If you simplify, when you simplify, this comes to 1500 upon 4. That means when you simplify, this comes to when you simplify, this comes to 375 rpm. 375 rpm. Now put this value in this equation. If you putting this, then rotor speed corresponding to maximum torque is 375 into 1 minus slip corresponding to maximum torque, that means 2 upon 15. After simplification, their value of speed comes to 325 rpm, approximately 325 rpm. So correct option for this question is what? 325 rpm, that means option C. Option C. Next, which of the following statement is correct regarding auto transformer? A part of winding is common to both primary and secondary circuit. Yes, in auto transformer, part of winding is common to both primary and secondary. Primary and secondary. This is auto transformer circuit, in which if you see this, that part of the winding is present in both primary and secondary side. primary and secondary side. Second, the two windings are not electrically isolated. Yes, this is also correct. In two winding transformer, primary and secondary winding are electrically isolated, but in auto transformer they are not electrically isolated. So this statement is also correct. That means both statements are correct. Both A and B are correct. Next, some outdoor distribution substation transformers are equipped with a tank on the top of the transformer called on the top of the transformer we use a tank called conservator called conservator. Here conservator is used for the expansion of aisle when the transformer is working. In this case, transformer aisle is heated, and when the aisle is heated, then in this case aisle is expanded. When the expansion of aisle happen, then this aisle is spread to the conservator part, as the conservator part is uh, above the transformer. Aisle is easily cooled, and then when the aisle is cooled, this aisle is again returned to the transformer tank.
Hi everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical and Electronics Engineering at YourPedia. Now in this we are going to see the questions, previous year questions and practice questions combinedly from the subject power systems, almost some 65 to 70 questions combinedly from the subject power system for your HPCL Electrical Officer CBT preparation. YourPedia is one of the best and largest platform in training the students for competitive examinations like HPCL, okay, and other competitive examinations, state level competitive examinations like PTSPL, Punjab and J&K services, whatnot. For all other competitive examinations, YourPedia is the best platform. If you have any queries related to course or any book and anything, you can contact us in the number that is mentioned in the description box. Okay, we made a very good book for HPCL JO preparation with more than 2500 questions, such that you can prepare any subject thoroughly from starting to ending by using that book. That way questions are made, right? Yeah, let us enter into the power system PYQs and practice questions for HPCL preparation, for HPCL CBT preparation, right? The very first question is from power system protection. Which device is most effective for over voltage protection in power system caused by lightning surges? You know, lightning surges, to protect transmission system or transmission lines from the surges, we are using, yes, we are using, see, lightning arrestor, not lightning arrestor, in fact that is called as earth wire, shield wire or ground wire. What is this? This is see, this is the cross arm, and yes, this is the cross arm, this is transmission line. Anyhow, here overhead line insulation will be there, here insulation will be there, but this is transmission line. Now whenever lightning stroke enters into the system, that is going to enter onto this earth wire. What is this wire? Earth wire or shield wire, shield, yes, shield wire or ground wire. Earth wire, shield wire or ground wire is used, okay, but that is also called as lightning arrestor. Yeah, it is arresting the lightning such that lightning is not going to, this is lightning stroke, this is lightning stroke, yes, this wire is making the lightning stroke not to enter into the transmission system. Option is A, lightning arrestor. Option is A, lightning arrestor. Next question. What is the main advantage of using high-speed circuit breakers in power system? What is a high-speed circuit breaker? Means within less time circuit breaker is going to open the contacts such that the system remains in stable mode. Yes, in the topic equal area criteria we will get all this. The circuit breaker and relay, there is a coordination. The relay circuit breaker, in fact the entire fault clearing time should be less than critical clearing time, then only system is stable. Otherwise, though fault is cleared, it is useless. It is going to be useless. The fault clearing time must be less than the fault clearing time must be less than critical clearing time. Clearing time. The fault clearing time must be less than critical clearing time for the system to be stable. Otherwise, it is like a patient got sudden heart attack. You are taking him to the hospital, but you must take him to the hospital within some time. Suppose after half an hour you are taking him to the hospital, there is no use. Why? Because he is with massive heart attack. Within some time we have to take him to the hospital. Sometimes doctor will say it is too late. In the same way, whenever fault occurs, relay must recognize the fault. It must give trip signal to circuit breaker. Circuit breaker must be in a position to open the contacts within some time. If that time is crossed, though the fault is cleared, circuit breaker opened its contacts, there is no use. There is no use. So what is the option? Enhances voltage regulation, nothing to do with the voltage regulation. Decreases system stability, no, we want more stability. Improves the system stability, option C is the correct answer. Option C is the correct answer. You have to go for the next option D. Why? Because 4 options, only 1 option is correct. 4 options, only 1 option is correct. Therefore, option is C. Next question. The Ferranti effect in AC transmission lines refers to which of the following phenomena? What is Ferranti effect? Let me write here Ferranti effect. What is Ferranti effect? Ferranti effect. Ferranti effect. Yes, during no load or light loaded conditions. During no load or light loaded conditions, receiving end voltage magnitude is greater than sending end voltage magnitude due to the charging current. IC stands for charging current. Charging current drawn by the transmission lines. Right? Ferranti effect is observed in medium and long transmission lines. In short transmission lines, it is neglected. It is not going to happen. Even in medium and long, in which Ferranti effect is high. In long transmission lines, Ferranti effect is high. Why? Because Ferranti effect depends on the capacitance. Capacitance depends upon length of the transmission line. Capacitance depends upon what? Length of the transmission line, right? That is called as Ferranti effect. Come here. The Ferranti effect in AC transmission lines refers to which of the following phenomena? Increase in line losses under heavy load, nothing to do with the losses and Ferranti effect. Voltage drop at the receiving end under full load, no. Rise in receiving end voltage at no load or light load, sometimes no load or lightly loaded conditions. Lightly loaded conditions. Yes or not? Option is C. Rise in transmission line, rise in the transmission line due to matching impedance, nothing. Resonance, sorry, not rise, resonance, nothing to do with the resonance and all. Ferranti effect means receiving end voltage magnitude is high compared to sending end voltage during no load or light load condition. Let's go to the next question. What is saying? What is the approximate critical distance beyond which HVDC transmission lines becomes more economical than HVAC transmission for overhead lines? You know, HVAC length is limited up to 400 kilometers. due to stability reasons. Okay, I'll write that point. HVAC is limited. HVAC length is limited up to, see, some books they are saying 400, 500, 600, up to 500 we can take on an average, 500 kilometers due to stability reasons. Means beyond 500 we can't go for HVAC, stability reasons, due to stability reasons. So beyond 500 we have to go with the HVDC transmission line, but HVDC transmission line is costly. HVDC transmission line is costly and it should be economical for us. Why it is costly, sir? We generate AC, right? We use AC, but in the middle, for the transmission purpose, we have to convert into DC. Means AC to DC. AC to DC means a rectifier station, all the things are required. Again DC to AC, inverting station is required. That converting station's cost is going to be very high and the losses in the converting stations are going to be very high. Converting station losses are going to be very high. That is the main reason we go for HVDC. But HVDC is economical. See, stability is the main reason why we are going for HVDC. Loss is one more reason. Beyond 500 kilometers, HVAC cannot be used. But HVDC is economical, means we are going to build costly converting stations. Okay, but that cost is economical for beyond 600 kilometers. Answer is what? 600 kilometers. Option A. Next. Voltage regulation of a transmission lines becomes negative. What is voltage regulation? Voltage regulation, generally let's take for short transmission line. What is voltage regulation formula? Percentage voltage regulation is equal to percentage resistance of the line into cos phi r. Yes, plus or minus percentage transmission line reactance into cos phi r, sin phi r, into sin phi r. Right, we want this one to be negative. See, plus for lagging loads, plus for lag loads, minus for lead loads, right? Now I want this one to be negative. Whenever plus is there, never it is going to be negative. Whenever plus is there in between, never it is going to be negative, but minus should be there. So answer should be for leading loads only. If minus is there and this part is more than this part, then only the regulation, voltage regulation is going to be negative, right? Means voltage regulation can become negative for leading loads, means capacitive loads, right? Capacitive loads. The power factor is unity? No. The load power factor is leading. Yes, the load power factor should be leading for, see, for leading, sir, is it guaranteed that, sir, for leading loads, is it guaranteed that voltage regulation is negative? No. Leading may be positive also. For leading load, three types of regulations are possible. Voltage regulation may be positive, maybe zero, maybe negative. I will draw voltage regulation curve. For better understanding. This is the voltage regulation curve I am drawing. Okay, this is lagging power factor side. This is lagging power factor side. This is leading power factor side, and this is UPF, unity power factor. Now this is percentage voltage regulation. I am drawing. Observe it, please. This is a percentage line resistance. Here voltage regulation is negative. Okay, you see, this is leading side only. From here completely this is leading side. Voltage regulation is positive, voltage regulation is zero, voltage regulation is negative, right? But the possibility of getting negative voltage regulation is existing only for, I repeat, the possibility of getting voltage regulation is negative is only for leading loads. Option is what? B for Bombay. Let's go to the next question. A medium transmission line delivers 80 megawatts. Okay, so load power is how much? 80 megawatts. So PR is equal to root 3 VR IR cos phi R is equal to 80 megawatts. Clear. At 132 kV, VR is 132 into 10 to the power of 6. With sending end voltage as 135 kV, he given Vs as 135 kV. All are magnitudes given. kV, please, not 10 to the power of 6. It is kV. 10 cube. Vs is 135 into 10 cube volts. Okay. losses are 1.5 megawatt, losses are 1.5 megawatt. Find the efficiency. All this is not required. Efficiency is equal to output is 80. Output is see what is efficiency formula? Efficiency is equal to output by input, percentage efficiency if you want, into 100. So output by input is what? Output plus losses into 100. Output plus losses into 100. So output is 80 by 80 plus 1.5. So efficiency is equal to, percentage efficiency is equal to, multiply with 100. 80 divided by 81.5 into 100. Just do this, you will get the answer. Just you must be good at calculation. Calculation part I am leaving it to you. Calculation part I am leaving it to you. Okay. I think this is, yeah. 80 divided by 81.5 into 100. All this is nonsense. No, need not to write. Next question. Under which condition an isolator typically operated? Isolator always operates under no load. What is isolator? It is going to increase the distance between the moving contact and in fact I can say circuit breaker is going to open the circuit, but the distance between circuit breaker moving contact and fixed contact is very small. The distance between circuit breaker moving contact and fixed contact is small. That distance may cause again the arc to restrike. Therefore, after circuit breaker opening, means no load. After no load happens, then isolator is going to provide the distance between the fixed contact and moving contact in terms of meters. Okay, isolator always operates. I'll write here. Isolator always operates under no load. Isolator always operates under no load, whereas circuit breaker operates under any condition, under any, means no load, full load, half full load, whatever it is, during faulty condition, under any condition. So operates means it can open, it can make the circuit, it can break the circuit. Circuit breaker can make the circuit, can break the circuit under no load condition. Option is B for Bombay. Option is B for Bombay. Next, distance protection relays are primarily used for the protection of which power system component? Distance protection for transmission lines, huge length. Okay, see, for the protection of transmission lines, protection of transmission lines, we use distance relays. What? Distance relays. For long transmission lines, we use more relay. For long transmission line, we use more relay. For medium transmission line, we use, I can say, reactance relay. Yes. No, we use impedance relay for medium transmission line. Yes, we use impedance relay. For short transmission line, yes, we use reactance relay. Okay, because in short transmission line, the resistance also will contribute for, I can say, yes, medium transmission line is this. Okay, medium transmission line is this. Short transmission line resistance is very small. Okay, so for transmission line protection, we are using distance relays. Let's go to the next question. Next question is looking like numerical, right? Yes, read the question. What is saying? Yes, all of you read the question. What is saying? A transmission line has receiving end voltage of 220 kV. He given receiving end voltage. Okay. Yes, 220 kV and a sending end voltage of 220 kV and a sending end voltage of 230 kV at full load. Sending end voltage of VR is given 220 kV, VS is given 230 kV. Okay, calculate the voltage regulation. Here something is missing. Yes, something is missing. See here, correct only. This is correct only. Yes, we use reactance relay for short transmission line? Yes. For in short transmission line, the resistance of the transmission line will hamper the relay operation. That's why we use reactance relay. Okay, correct only. This is correct. Medium transmission line impedance relay. Why? Because medium transmission line is impedance relay, short transmission line is reactance relay. Correct. Correct. Now here, sir, what is voltage regulation formula? Voltage regulation is equal to, yes, what is voltage regulation? No load receiving end voltage minus full load receiving end voltage by full load receiving end voltage into 100 percentage voltage regulation, right? But sir, this is not given, but he given sending end voltage for short transmission line. I repeat, for short transmission line. For short transmission line, no load receiving end voltage is exactly equal to sending end voltage. And as he did not given this one, we take this one is equal to this one and we assume that it has short transmission line. Why? Because the type of the transmission line is not mentioned by him. He did not mention what kind of transmission line is this. So 230 minus 220 divided by 230 into 100. Yes, how much it is? 10 divided by 1000 divided by 1000 divided by 230, 0 gone. 100 divided by 23. 100 divided by 25 means 4 point something, right? So 4 point something. Yeah, this is also, it should not be 5 because it is exceeding 100. So 4 point something you have to get. It is not exactly 4. See, first of all, it is not 5. It is not 5. It is not more than 5. It is not equal to 5, not more than 5. I am not doing the complete calculation, elimination. It is not exactly 4 also. If it is, it should be exactly 4. It should be 25, but it is 23. More than 4. Option is 4.55. That's all. Eliminate it. Next question. A short transmission line delivers 50 megawatt power at 110 kV with a line current of 300 amperes and a line resistance of 15 ohms. Calculate the efficiency. He is asking for the efficiency. A short transmission line delivers 50 megawatt. Okay, output power is 50. Okay, 110 kV with a line current of 300 and a line resistance of, yeah, he is given current he given. Power loss is what? Power loss is equal to 3 times of I square. How much it is? 300 whole square into resistance is 15. 3 into 9 into 10 to the power of 4 into 15. 10 to the power of 4 into 15. This is power loss. So 3 into 9. 27 into 15 into 10 to the power of 4. Let me do that. I am using my cell phone calculator for doing that. I am using my cell phone calculator. Just a minute. 27 into 15. Okay, 405 divided by 100 I do. So 4.05 into 10 to the power of 6 you get 4.05 megawatts is the loss. Now what is the efficiency? Just now we did. Efficiency is equal to output is 50 by output plus loss is 4.05. So 50 divided by 54.05. If I want percentage efficiency, multiply with 100. So 50 divided by 54.05 into 100. How much it is? 92.50. Exactly how much? 92.50 percentage. 92.50 percentage. Option is C. Simple question. You see, on efficiency 2 questions were asked, right? Next question. What is the correct formula for calculating the voltage regulation of a short transmission line supplying leading power factor load? This one we already saw. This one we saw already. Yes, we saw. What is that? Yes, IR into percentage RL I taken previously. Yes, I given you the formula. In fact, here I given. Percentage RL is nothing but what? Per unit value by base. Right? IR into RL cos phi r, as it is leading load, in between minus should come. IR into XL sin phi r divided by mod VR into 100 is nothing but percentage voltage regulation. Is nothing but what? Percentage voltage regulation. If you take I common, I into cos phi r minus X into sin phi r. Option is A for apple. Option is A. Observe it, please. Observe it. Option is A. Yes or not? Yes. Next question. Buckholes relay is primarily used for the protection against which of the following? Buckholes relay is used in the transformer. It is a relay which is going to recognize slowly developing faults, which are also known as incipient faults. Okay, it is not going to means it not the instantaneous fault, slowly developing faults. It is going to measure the oil level in the conservator tank, in the transformer conservator tank. Buckholes relay will observe, or it is going to recognize the slowly developing faults called as incipient fault, and that to internal faults of transformer. Over voltage of the transmission lines, no, nothing. Buckholes relay is nothing to do with the transmission line. External short circuit of transformers, no. Internal faults of transformer, yes. It is placed such that internally any fault is developing slowly, incipient fault. The slowly developing fault is also called as incipient fault. See, internal faults in transformer are slowly developing or incipient faults in transformer. Yes, option is C for Chennai. Next question please. The per unit value of any quantity is defined as, per unit is equal to, per unit value or quantity is equal to absolute quantity or just quantity. Absolute quantity in units, in some units by base quantity, yes, by base quantity in same units. So this is some units. What this is having units, the same unit it is having, it should have the base quantity, same units. Actual value or absolute, or it is also called as actual in is language, actual quantity. Base value, no. Actual value in any unit by base value in any unit, not any, same, both should be same. Base value, no. Actual value in any unit by base value in the same unit. Option is D for Delhi. Option is D. Next, zero sequence current will not flow in. Zero sequence current will not exist in the lines. Okay, why? Because if you take line current IAB is equal to what? IAB is equal to what? IA minus IB. What is IA? IA is IA0 plus IA1 plus IA2. IB is what? IB0, which is equal to IA0. IB1, which is nothing but alpha square times of IA1. IB2 is nothing but alpha times of IA2. So IA0 will get cancelled. Zero sequence current will never exist in lines. Okay, 3-phase to ground fault, line to line fault, yes. Whenever, see, if the fault is not associated with the ground, I repeat, zero sequence current will exist if three conditions should be satisfied for the existence of zero sequence current. Three conditions should satisfy. One is, see, there should be ground. I'll write all 3 points. I'll write in the form of document here. Observe. Yes. Zero sequence current to exist. Zero sequence current to exist. The following conditions must satisfy. The first one is neutral grounding must be required. Neutral grounding should be there. Yes, all 3-phase machines, neutral grounding must be there. Second one, fault must be a grounded fault. Fault must be a grounded fault. Fault must be a grounded fault. Third one is, yes, neutral grounding must be done. Fault must be a grounded fault, right? Third one is, I can say, system must be unbalanced. In balanced condition, yeah, 3-phase fault is balanced fault, no zero sequence current. System must be unbalanced. So these are the three different conditions that need to satisfy for the flow of zero sequence current, right? We take an early option. Next question. Which of the following best describes the role of conductance G in transmission line? What is conductance G? If you take a transmission tower, just a minute. If we take a transmission tower, this is cross arm. Here we are putting overhead line insulators. These are overhead line insulators. Some leakage current, this is ground. Some leakage current will flow from conductor to the ground. Some leakage current will flow from conductor to the ground. This is because of this is mega ohms of resistance, which is going to have some conductance G. What is G? 1 by mega ohms. That implies micromhs. So conductance G represents the leakage current that is flowing from conductor to the ground. Conductance G mainly influences the reactive power, nothing to do. Conductance G represents the efficiency of the transmission line by reducing line losses, nothing to do. Conductance G is responsible for leakage current between the transmission line conductors due to imperfect insulation. If it is a perfect insulation, this should be in infinity, then G should be something by infinity should be 0. But that much perfect insulator is not available in this real world. That's why it is because of imperfect insulation. Option is C. Next question. Gauss-Seidel method load flow convergence. Load flow undergoes dash convergence, geometric convergence. Yes, Gauss-Seidel method undergoes. This is just remember. Okay, don't go in depth. Okay, this methods, depth of these methods we will get in masters. In bachelor's, just we will remember what kind of method is going to have what kind of convergence characteristics. That's all. Next, what are the primary constraints in power system and what is another term used to describe them? Okay, see, they are constraints related to equipment limitations and are also referred as economic constraints, not related to equipment limitations, no. Next, they arise from necessity to balance load demand and generation, are called as equality constraints. Yes, this is, yeah, we have in power system, in economic load dispatch, we have equality constraints and inequality constraints. Let's read option C also. There are constraints related to economic factors and are also known as inequality constraints. But it should be balance between demand and generation. Yes, how much is the demand, how much is the generation, right? They refer to maximum allowable power. No, they refer to, see, partially B and C both are correct. Okay, they are constraints related to economic factors. Yes, okay, there is a factor called a Lagrangian multiplier, okay, which is going to take care of that rupees per megawatt hour. So option C is correct. Okay, why? Because in terms of economic load dispatch, we speak about inequality constraints and equality constraints. Both are there. Okay, yes, option C is most suitable here. Which of the following is not voltage control method in power system? What are the different voltage control methods? Shunt capacitor, series capacitor, synchronous condenser. These three are used to increase the voltage. Shunt inductor, series inductor, synchronous coil. These three are used to reduce the voltage. Here voltage control is said. He did not mention either voltage to increase or to decrease. Both will consider to decrease and increase. But here shunt capacitor, yes, this is a method, but he's asking which is not a method. Voltage regulation is nothing to do. First of all, voltage regulation is not a method. Voltage regulation is simply a formula which is used to find the difference of voltage from no load to full load at the receiving end side, right? Series capacitor will improve the voltage. Tap changing transformer also, yes, with help of transformer tap changing. If we change the tappings, definitely voltage is going to change. Next question, option is B. Which variables are specified by slack bus in load flow studies? See, slack bus will have mod V comma delta. These are known values. These are known. Unknown are P comma Q. What are the unknown? Unknown are P comma Q. Then load bus. Yes. Then load bus. Load bus is also called as PQ bus. The name itself says PQ bus. Known, unknown. Known, unknown. The name itself says PQ bus, na? PQ bus. P comma Q are known, unknown are mod V comma delta. Then generator bus, yes, this is also called as PV bus. Known are P comma mod V, unknown are Q comma delta. Okay, so mod V comma delta are specified or known quantities. Mod V comma delta. Option is B for Bombay. Next, yeah, in power system the slack bus or swing bus, yeah, another name for slack bus is swing bus, is a special type of bus where the voltage magnitude and phase angle are specified. Okay, correct, previously we discussed that only. What is the primary function of the slack bus in power system analysis? Slack bus is a reference bus, so this is the bus which will supply any extra amount of power requirement, or if any extra power is there, it is going to absorb. Means it is like our father. If we need money, he can give. If we have excess amount of money, he can take. Both the works he will be doing. Slack bus is like our father. Let us read the options. What he is saying? First option, it specifies the role, it specifies the real power and reactive power while the voltage magnitude and phase angle are calculated. No, it specifies voltage magnitude and phase angle and adjusts its real and reactive power output to balance the system. Option B is perfectly correct. Option B is, yes, it is, see, the bus which is having the biggest generator or large capacity generator is taken as slack bus. The bus which is having large capacity generator is taken as slack bus. Means slack bus is going to take the power or give the power. Means simply it is going to balance. Simply it is going to what? It is going to do the balance. Simply it is going to do the balance. Right? Yes or not? Yes. Let's read options, other options also. It specifies voltage magnitude phase angle and do not contribute to real and reactive power. No, the main purpose is to contribute for real and reactive power. It can take, it can give. It maintains the voltage and magnitude and the magnitude and phase angle while the real and reactive power is calculated based on the load. No, it is going to contribute. Means any excess amount of power is there, it can take. Any deficiency of the power is there, it is going to give. It is any deficiency of the power is there, it is going to give. So it specifies voltage magnitude and phase angle and adjusts its real power and reactive power to balance the system. Option is B for Bombay. Right? Yes or not? Yes. Come here. Next question. A fully transposed transmission line has fully transposed. See, for a transposed transmission line, positive sequence impedance is equal to negative sequence impedance, that is equal to ZS minus ZM, ZS minus ZM. Zero sequence impedance is ZS plus 2 times of ZM, which is almost 2.5, 2 to 3 times, 2.5 times of Z1 or Z2. This is the relationship. Equal positive and negative sequence impedances, correct. Equal negative and zero sequence, never. Positive sequence impedance is 0, no. Equal positive and zero sequence impedances, no. Option is A. A fully transposed transmission line, positive sequence and negative sequence impedances or reactance are exactly equal, and this is the relationship between positive sequence, negative sequence and zero sequence impedances. Next, which of the following statements accurately describes the role and impact of electric power in modern society? Yes, this is, see, we must be worried at this kind of theory questions. Why? Because these questions will really test our thought process. Okay, read the first option. The use of electric power is limited to industrial. No, see, the use of electric power is not limited to industrial. It is everywhere. Electric power usage is everywhere. Economic circumstances do not influence the development and use of electric power in country. No, economic circumstances will influence. Why? Because we see new technology, new equipment. If you want to purchase, definitely those are going to influence. Na? Economic circumstances will influence. Electric power is influenced by history, yes. Tradition, yes. Economic circumstances, and is essential for industrial development and public convenience. Yes, option C is perfectly correct. Yes, it is influenced by history, tradition. You know, if you go to countries like US or Japan, they are most advanced. Their history, their tradition is related to electric power generation. We recently adapted using lot of electrical energy, right? Option C is perfectly correct. right? Next, for a fault in power system, the term critical clearing time is related to severity. Yes, I told you the fault must be cleared before the critical clearing time, in terms of angle, before the critical clearing angle. Otherwise system will be unstable. Okay, the critical clearing time, critical clearing angle, these are related to what? Stability. Steady state stability, relative stability, transient stability. Yes, steady state stability means small disturbances. Okay, small disturbance stability is studied with help of rotor load angle, delta less than 90 stable, delta less than beta stable. What is steady state stability? For small disturbances, and this is studied with help of power transfer equations. Small disturbances, delta less than beta stable, delta greater than beta unstable, delta equal to beta marginally stable. Relative stability nothing to do, absolute stability nothing to do, transient stability. Power system stability is classified into I can say steady state, transient and dynamic. Okay, these are the three classifications, right? Next question. Some outdoor distribution substation transformers are equipped with the tank on the top of the transmission of the transformer called as conservator tank, in which expansion and contraction of the oil takes place. Yes, oil, when heat increases it expands, heat decreases it is going to contract. Conservator tank. What is that? Conservator tank. Yes, it is conservator tank, which is kept on the top of the transformer, right? Next question. In potential transformer, the secondary winding is designed so that a voltage of dash is delivered to the instrument load, 100 to 120 volts. This is a practical value to remember. Okay, nothing to discuss much about it. The purpose of that PT is to reduce the voltage to a value in between 100 volts to 120 volts. One should remember that value, that's all. Okay, no much discussion on that, right? Next, differential relays are commonly used to protect transformers with ratings larger than 10 MVA. Yes, see, I'll write differential relays. Differential relays are used to protect transformers, with ratings larger than 10 MVA. Option is C for Chennai. Next, a relay that operates on the basis of voltage to current ratio. Yeah, what is voltage to current ratio? Impedance. That is impedance relay. It is not current relay, it is not conductor relay, it is not voltage relay, it is impedance relay. This is a direct question. The relay that operates depending on voltage to current ratio is called as what? Impedance relay. HVDC transmission needs only two conductors. Yes, two conductors. It requires two conductors. One is positive, another one is negative. Okay, here it is the load, positive conductor. This is conductor 1, this is conductor 2. It requires two conductors. Option is A. It requires two conductors. Okay, next, which of the following is correct regarding potential transformer? Okay, potential transformers are used to operate voltmeters. Correct. The potential coils of wattmeter and relays are from high voltage lines. Yes, correct. Statement 1 is correct. Yes, the purpose of PT is to reduce the voltage, right? Next, the design of potential transformer is quite similar to that of power transformer, but the loading on the potential transformer is always small. Sometimes it is only few volt amperes. Perfect. Statement 2 is also correct. Both 1 and 2 are correct. Next, directional relays are designed to operate for fault currents in only one direction. Yes, directional relays are used to operate only in one direction. Right? Next, many distribution substation transformers have load tap changers. Okay, What is the purpose of load tap changes? Read the options and give me the answer. Read the options and give me the answer. Good question it is. Yes, what is the purpose? Load tap changes manually regulate frequency levels based on loading conditions. We'll see. Load tap changes automatically regulate voltage levels based on loading conditions. Load tap changes does not regulate voltage levels based on loading conditions. Load tap changes manually regulate voltage levels. I will tell you, with the transformer frequency cannot be controlled, na? So nothing to do with the frequency first of all. Yes, nothing to do with the frequency. Yes, therefore frequency options are eliminated. Okay, means option A is eliminated. Load tap changes automatically regulate voltage levels based on load conditions. Load tap changes does not regulate. Load tap changes regulate this voltage. Yes. Yes or not? Yeah, read the option and tell me the answer. Yes, yeah. So does not is there in option C. Option C is also eliminated. A, C are eliminated. Either B or D. What is B? Load tap changer. Okay, automatically regulate voltage levels based on loading condition. Option D is load tap changes manually. See, LTCs automatically regulates voltage in electrical transformers. Yes, based on load conditions. Yes. New technologies are there. Automatic control system is there with which the LTC operates in LTC is going to operate in conjunction with the automatic voltage regulator. Okay, so load tap changers automatically will do this job. Option is B. Option is B. B for Bombay. See, maybe as per the question paper he may given something else, but LTCs automatically regulate voltage levels based on loading conditions. They are going to work in conjunction with automatic voltage regulators, AVRs. What is corona loss? See, corona loss, power loss, PC, power loss due to corona is directly proportional to F plus 25. F plus 25. Okay, corona loss, power loss because of corona is directly proportional to F plus 25. Option is D. Option is D. If a frequency is going to increase, corona loss increases. In DC, corona loss is less. See, don't misunderstand. In DC, corona loss is not going to be there. It is there. DC means F is equal to 0. 0 plus 25. In India, what is frequency 50? 50 plus 25 means in DC, corona loss is directly proportional to 25 for DC. In AC, corona loss is directly proportional to 75. Therefore, corona loss in AC is greater than corona loss in DC. In DC, right? Option is D. Next question. Which of the following is correct regarding secondary distribution? Secondary distribution distributes energy at consumer utilization voltages from distribution transformers up to meters customer premises. Correct. In residential areas, 120 by 240 single phase 3-wire system, 3-wire service is the most common. Yes, sir, 240 volts, not 120. In fact, in India it is 240. Okay, in US it is 120 volts. Okay, and household appliances, both 1 and 2 are correct. Both 1 and 2 are correct. Right, both 1 and 2 are correct. Simple statements only. The ratio of voltage across the whole string, total V phase, whole string. Okay, product of number of units, product into voltage across the nearest to the line means Vn will be string efficiency. If you take this one into with 100, this will be percentage string efficiency. What is this one? Percentage string efficiency. Option is A. Percentage string efficiency. Total applied voltage by number of strings into voltage across the nearest string to the conductor will be string efficiency. Next. Which of the following is known as spool insulator? Spool. Another name for spool insulator is a shackle. Shackle insulator, which we are going to place like this way at the dead ends or at the road curvatures or railway crossings or railway curvatures. Okay, railway crossings or river crossings we are going to use. This is spool or shackle. Spool or Shackle insulator, right? Shackle insulator or spool insulator. Next, dash or egg shape stray or guy wire, stray wire or guy wire insulators, egg shape. Okay, need not to read the entire statement. Okay, so answer is it is not pin type, not shackle, not post. Post insulators we use in substation for placing bus bar. To place bus bar in the substation, in substation we use post. We use what? Post insulators, right? Let's go to the next question. Which of the following is the advantage of HVDC transmission? Okay, HVDC transmission. No skin effect, S. Negligible sheath loss, S. Rapid change of energy flow, yes. Yes, see why? Because this reactance is there, na, X, it will not allow sudden change of current. But with DC, yes, no such kind of possibility. Means X is equal to 0 for DC. Sudden change of current takes place. What is energy? Half Li square. L will be there. L is not equal to 0 for inductor for DC. L will be there. XL will be 0, right? So I guess all three are correct. No skin effect. No skin effect. Option 3 is correct. Negligible sheath loss, that is also correct. Right? Rapid change of energy flow. Yes, sudden change of energy. Not sudden change, rapidly it will flow. Right? Next question. Which of the following statement is correct regarding the usage of insulators in transmission? Insulators provide proper insulation and a necessary cleanliness against highest voltage in the worst atmospheric condition. Correct. The insulators also prevent short circuiting between the different phase conductors and provide necessary mechanical support for line conductors. Both 1 and 2 are correct. Both 1 and 2 are correct. Simple statement. Next, for a long transmission line, the ABCD parameters are used to characterize its performance. Which of the following describes the relationship between the voltage at the sending end, Vs, and the voltage at the receiving end, Vr? Very common. Vs is equal to AVR plus BIR. Is is equal to what? CVR plus DIR. Vs is equal to AVR plus BIR. Vs is equal to AVR plus BIR. Option is A. Option is A for apple. Right? Next, in the context of an infinite bus bar, which parameter remains constant regardless of the connected alternator support? Frequency. Always frequency must be constant, then only parallel operation takes place. Otherwise it is not possible for the parallel operation to happen. Frequency must be constant. Power factor, reactive power current, these need not to be constant. Frequency, magnitude of voltage, phase sequence. See, for parallel operation of alternators, for parallel operation of alternators, magnitude of the voltage, phase sequence, comma, frequency must be same. Phase sequence, magnitude of the voltage, phase sequence and frequency must be same. Right? Next, for a short length transmission line, the voltage regulation is primarily influenced by voltage regulation, series reactance. See, the formula is this: percentage voltage regulation is equal to percentage line resistance into cos phi r plus or minus percentage line reactance into sin phi r. So which will influence? Line resistance, line reactance and power factor. Whose power factor? Load power factor. These three. Read the series reactance and shunt capacitance. Shunt capacitance is nothing to do because short transmission line shunt capacitance is neglected. Only the series reactance? No. The series reactance and the series resistance and line inductive reactance. Perfectly correct. Option is C. The series resistance and the load power factor. Load power factor also will influence actually, but reactance is main. Then resistance, then power factor. Actually, to speak all three he must mention. Next question. For a short length transmission line, the voltage regulation is primarily influenced by the previous question only. It's repeated. The critical clearing time depends upon which of the following factors in the power system? It depends upon the reactance. It depends upon the See, I'll tell you. Let's read the options. See, critical clearing time, the type of fault and the location of the fault, the fault impedance and line resistance, nothing to do with the line resistance, leave the resistance. The total system load and generation capacity, this is nothing to do. Voltage at the fault condition, no. The type of fault and location of fault. The location of fault itself will decide the reactance. So this will decide reactance. This will decide reactance. See, if type of fault, for LG fault, for LL fault, for triple fault, the critical clearing time is different. Okay. Next, for a transmission line with insulator string, if the string efficiency is low, which of the following can be potential consequence? String efficiency is less than 100% because the disc near to transmission line is going to share more voltage compared to the other discs. Okay. Increased voltage across the first insulator unit, potentially leading to insulation breakdown. Option A is correct. Yes, the disc near to transmission line will share more voltage. This is transmission line. Okay, this fellow will share more voltage compared to other fellows. Because of this, this will fail, then this will fail, then this will fail. The total string is going to fail. Option is A. Next, during an unsymmetrical fault such as line to line fault, okay, the transmission line typically experiences, it is first of all an unbalanced fault, it is not balanced. A complete voltage drop in the faulted phase only, no change in the line's impedance, no. The current unbalance between the faulted phases and the unaffected phase, yes. Option D. Yeah, AB on A and B or B and C, the fault is happening in those two phases, current is not same as that of the unaffected phase. Unbalance is going to take place. Option is D. In case of single line to ground fault, the fault current is primarily determined by, what is the fault current formula? Let's write fault current formula. Fault current is equal to 3EA1 by Z1 plus Z2 plus Z0 plus 3 times of Zn plus 3 times of Zf, which is equal to 3 times of Ia0, that is equal to 3 times of Ia1, that is equal to 3 times of Ia2. Right? The zero sequence impedance of the system, no, it requires positive, negative, zero, all. The system impedance including line and ground impedance, yes, perfect. Yes, neutral grounding impedance, in fact fault impedance is also required. Negative sequence impedance of the system, no. Positive sequence, no. It requires total system impedance along with the neutral grounding impedance and fault impedance also, in fact. Right? Next question. In overvoltage protection schemes, what is the primary purpose of the voltage transformer used in the protection system? To reduce the voltage, right? To step down the fault voltage, to isolate the protection system relay from high voltage system. Yes, that is also correct. See, the overvoltage protection to isolate the protection relay from the high voltage system. Yes, it is. Yes, overvoltage. Yeah, see what happens is, this is, yeah, here we are going to put relay, okay, means here fault is there, here over voltage is appearing here, so that part is isolated, in fact, to step down the fault voltage, this is also correct, A and C both are correct. Yes, the purpose of voltage transformer, yes, this is PT, potential transformer, this will step down the voltage also, but mostly we'll take option A. Next, which of the following load flow methods uses the bus impedance matrix? Yeah, we have bus admittance matrix mostly used in Newton-Raphson, Gauss Seidel and all. Okay, there is one method, Gauss elimination method, that is Z-bus or Gauss elimination method for the study of I can say load flow, for the study of load flow. Z-bus or Gauss elimination method is used. Next, for a three-phase fault in a balanced power system, the fault current is primarily determined by, as the three-phase fault is a balanced fault, three-phase fault is what? It is a balanced fault. As it is a balanced fault, the fault current IF is equal to EA1 by x1, only positive sequence. Negative sequence, nothing. Total system impedance, nothing. Positive sequence impedance of the system. Option is C. Option is C. Right? Next, the per unit system is used in power system analysis mainly. See, per unit is going to reduce the complexity of the calculation, and it is going to eliminate that I can say coupling transformers equations. Two things are there. Let's read the options. Improve the precision of the load flow calculation, nothing. Increases the complexity. If complexity is increasing, why the fun we use all that? Okay, we are not going to use. Maintain consistency in physical units across the calculations. We'll see this. Simplify the comparison of electrical quantities across different levels. Yes, option D is perfectly possible. Yeah, see, 10 volts is the drop, 100 volts is the drop. Which one is more drop? You will say 100 volts. No, 10 volts on 1000 volts, 100 volts on 1 megavolt. Okay, so which one? Then that comparison is possible only with per unit. Yes, per unit is, see, per unit advantages is first one, reduces complexity. Per unit reduces complexity. Second one is transformer coupling circuit is removed. Coupling circuit is removed. That is one of the advantage. Third, very important. Second one is also very, very important. All three are very important. Third one is comparison is possible. Comparison is possible. Comparison is possible at different levels. At different levels. Okay, so option is D. In Newton-Raphson method of load flow analysis, the size of the Jacobian matrix. Jacobian is simply 2n minus 2 by 2n minus 2 is the size of the Jacobian matrix. That is the size of Jacobian matrix. Option A. Okay, next. In Newton-Raphson method for load flow analysis, the update of voltage magnitudes and angles are performed using inverse of the Jacobian matrix. Yes, the inverse of the Jacobian matrix multiplied with the power mismatches. Yes, see, del delta del mod V is equal to Jacobian whole inverse into delta P delta Q. Del delta del mod V is equal to Jacobian whole inverse into delta P delta Q. Option is C. C for Chennai. Next, the percentage reactance of an element is 20% and the full load current is 40%, then the short circuit current will be, short circuit current is equal to rated current by reactance. How much it is? 0.2. How much it is? 80 amperes. No, is it 80? Let me calculate. 400 divided by 2. It is 200 amperes. Sorry, it is not 80. 200 amperes. Option is B. B for Bombay. See, short circuit current is equal to rated current by reactance in per unit. Reactance in per unit. Right? The simple question that is. Next question. A conductor that connects the distribution substation and the area where power is to be distributed is known as a distributor. It is distributor. See, I'll tell you, transmission line is called as feeder. This is feeder. That comes to distribution substation. This is a distribution transformer. Okay, and this is a distributor. This is what? Distributor. Okay, on distributor there are different loads. Different loads. This is house 1 or house 2. And this particular wire is called as a service main. Service main. And there is a small length cable which is used to connect the home, this distribution line to the home. It is called as submain. This is called as submain. Every means see, this is service main, means from distributor to your home. From home, see, from this from service main to the home, exactly it is going submain. It is called as what? Submain. Next question. A DC 2-wire feeder, the drop of feeder contributes 2%. Find the transmission efficiency. So he is asking about transmission efficiency. There is one formula. Okay, there is one formula to do that. Yes, any one of you? Yes, any one of you have any idea which formula we have to use? See, actually, as it is a two-wire feeder, na. See, there is a forward wire, there is return wire. What is saying 2%? But 2% plus 2% will be 4%, na. Yes. Yes, total 4% is the drop. 4% is the drop. So efficiency is equal to 100 minus drop percentage. This is the formula. Okay, 100 minus 2% is forward wire plus return wire is 2%, total 4%. Answer is 96%. This much simple it is. You have to remember this one you remember. Efficiency of the feeder. Yes, that is what? Efficiency of the feeder. Next question. Which of the following is an example of symmetrical fault? Symmetrical means which is happening on all three phases of the transmission line at a time with the same impedance. Symmetrical is also called as balanced fault. Symmetrical or balanced fault. Symmetrical or balanced fault. Option is A, triple L. Not LLG, not LG, not LL. Next question. Which fault is indicated in the given diagram? Okay, diagram is missing in this. Leave it off. A 350 kilometer line is considered as long transmission line. See, length less than 80 km, short transmission line. Length is greater than 80 but less than 160 kilometers. Yes, medium empty line, medium transmission line. Length greater than 160 kilometer, long transmission line. What is this? Long transmission line. Option is C. Option is what? C. Next question. A uniform 2-wire DC distributor is 200 meters long and it is loaded with 2 ampere per meter. See, 2 ampere per meter, small I is 2 ampere per meter. What is the total current, capital I? What is that? 2 ampere per meter into number of meters. How much it is? 200. How much it is? 400 amperes. Yes. Or in another way also we'll do that. 2 ampere per meter, 200 meters long. The resistance of single wire is 0.3 ohm per kilometer. How much it is? 0.3 ohm per kilometer. Calculate the maximum voltage drop if the distributor is fed from one end. If it is fed from one end, maximum voltage drop formula is capital I, capital R by 2. Capital I, capital R by 2. What is 1 by 2? Keep it aside. Okay. Current, how much he given? See, what is capital I? Somewhere, some typo. 0.3 ohm per kilometer. If 0.3 ohm per 1 kilometer for 200 meters. 200 meters means how many kilometers? 200 meters means how many kilometers? So 0.2 kilometers, na? Why? Because 1000 meters is 1 kilometer. Then 200 meters is x kilometer. X into 1000 is equal to 1. X is equal to 200 divided by 1000. 0.2. Okay. So 0.2 kilometers. How many ohms? Let's take it as x ohms. So x is equal to 0.3 into 0.2, 0.06 ohms. Yes, 0.06 ohms is the total resistance. 400 into 0.06, this is 200 times, yes, 0.6 into 20, yes, 6 into 2, this is 12 volts simply. Answer is what? 12 volts. Option is B. Very simple. Formula you have to remember. Capital I is the total current, 400, right? Capital R resistance is for 1 kilometer, for 200 meters. For 1 kilometer, 0.3 ohms. For 0.2 kilometers, how much it is? X ohms I taken, which I got as 0.06. So I multiplied, I got it as 12 volts. Next question. If the percentage reactance of the system up to the fault point is 20% and the base KVA is base KVA is 10,000, KVA is 10,000, then the short circuit KVA is short circuit KVA or MVA, short circuit KVA is equal to base KVA by reactance, per unit reactance, base KVA by reactance. How much it is? 20% means what? 0.2. So 10,000 KVA divided by 0.2, you do 0.2, you do. Then how much it is? This is 10,000 means 10 to the power of 5 divided by 2 means 110. 5 into 10 to the power of 4 means 50,000. 50,000 KVA. 50,000 KVA will be the answer. Option is B. B for Bombay. Right. Next question. Per unit quantity. Already we got this. Okay. Actual quantity by base quantity. Actual quantity by base quantity. Actual value by base value. Right. In a transmission system, the cost of the conductor is proportional to the dash of the conductor. Cost is directly proportional to volume of the conductor. Directly proportional to volume. Yes. But the volume of our conductor is this way. Our conductor is this way. This is the length of the conductor. This is the cross section area of the conductor. Volume is equal to area into length. Therefore, cost is directly proportional to area. So, as length is not mentioned, volume is not mentioned, nothing depends upon color, smoothness, temperature, nothing. Option is A. Next. In a 3-phase 4-wire unbalanced system, the magnitude of the zero sequence current is 4-wire unbalanced system. See, IA naught is equal to IB naught is equal to IC naught. See, this is 3-phase, na? This is a neutral grounded wire. This is IA, this is IB, this is IC, this is IN. Okay. Yes, is equal to 1 by 3 times of neutral current. That is 1 by 3. How much is the neutral current? IA plus IB plus IC. It is 1 by 3 times. 1 by third, 1/3, option is B, 1/3. In a 3-phase 4-wire unbalanced system, the magnitude of the zero sequence current is dash the current in the neutral wire, 1/3, it is 1/3, right? See, we are done with almost 60 questions in power system for HPCL electrical officer preparation. All the corners of the power system we touched, starting from transmission, generation to protection. Generation we had some questions. Okay, this includes PYQs and practice questions. Yes, sir. We started with the generation, then after the transmission, distribution, faults, stability, load flow, protection. Okay, everything we covered, right? If you have any queries related to any subject preparation for your HPCL officer preparation, you can contact on this number. Even if you have any query related to the module of the preparation for your HPCL officers, you can contact us on the description, on the number that is mentioned in the description box, or the number that is displayed on the screen. Okay, for either of these two numbers you can contact us. Thank you.